Okay, so this week, Vivian will be presenting. Just as a note, this will be sort of a follow-up from last week's meeting. So in case this is, for whatever reason, your first video of TP or just jumping into a random video, I highly recommend you to watch last week's presentation by Jeff. And This week, Vivian will be kind of giving a alternative view, I guess, of keeping state variables in morphological models. So we thought about the idea of maybe not having that last week or just having it in the behavioral models. Uh, but we'll talk about the implications here. And I think Vivian, you made like a really extensive Excel job. I didn't look through everything, but I'm really excited actually. So yeah, feel free to take it over.
Okay, cool. Yeah, thanks. And yeah, we can see where I guess today's discussion goes. When I started making the board, I kind of started out just with the goal of visualizing the problem that we're trying to solve and then kind of talking through, like, making it clear what the actual difference is from how we did it before and what the proposal is of removing state, and then kind of highlighting the issues that we still would need to solve with that proposal and kind of the implications of removing state from morphological models. So I can go through that in however much detail we want to. We can also dive into the open problems and see if we can how we could address them. Those are the lines in red. But I also, like, while making it, was thinking a bit about, okay, could we solve the initial problem in a different way? And I think I have a potential alternate solution that kind of is the best of both worlds. So we could also just at a high level compare them and then go into this before trying to address the issues with this proposal.
Do you want do you want to just start with the alternate proposal?
Yeah, I can. Maybe I'll start with the problem first, just so it's kind of clear what we're actually trying to solve.
Okay.
Um, so, I mean, it's pretty straightforward. You already explained it yesterday, last week. But basically, an object can have many different behaviors at different locations. Like a car can turn its lights on and off, the left light, right light. The wheels can be spinning. Each of the doors can open independently. The trunk can open. The blinker can go on. The radio can be on. There are tons of behaviors on the car, and there could be many combinations of these behavioral states. So the question was, how could we capture all of them with a state variable? We don't want to learn a state for each possible combination because that's kind of a combinatorial explosion. And then, yeah, generally, how or when would we learn a new state of the car if the car had states? Um, there was also a kind of separate problem we talked a bit about in Milan, and the alternate proposal addresses it. So I just wanted to mention it too. But I don't think you talked about it last week. But basically, another issue you highlighted, Jeff, was that sometimes the state of the child can't be determined without the parent. So the child's state is defined relative to the parent. So, for example, the rocker, uh, the rocker itself just has an orientation, but its state, like whether it's flipped up or down, is defined by how it is rotated relative to the light switch plate. Um, and so, yeah, just kind of
I didn't know.
that was
It's interesting. Right. I think that a question I'm just thinking about is there ever that's not the case? Because
right.
we've just I think it's always the case, but I might be wrong. But I'm having trouble thinking of an example where that's not the case. That is
Yeah, I think at least with
a child
pose
object can.
changes. I think maybe with the light being on or off, like if the feature changes, if a feature defines the state, maybe that could be just
Right.
inferred by the child. But
But
yeah,
there's another way of thinking about it. You can think of the light as the light can have its own state. It's a light bulb. It's on or off. Um, uh, you know. anyway, we can get there, but it's like something like the hinge on the stapler. Well, if the child is at the top of the hinge, you can't say if it's up or down without looking at the rest of the stapler. So you're right. There
Yeah.
might be. I was just under the assumption this is always the case, but I could be wrong about that. But it doesn't matter. It's
Yeah, at
it,
least
it,
in a
it,
lot of cases, this would be like I would say this would be the
I,
default
yeah, I
that you
didn't view
need
this as
the
an
parent.
issue. I view this is just the state nature of the problem, and not like it's an issue. Um, that's how I thought of it.
Yeah, I think it was more that like sometimes when we talked about it, we were talking about, oh, the rockers in the on state or the rockers in the
Right,
off
right,
state,
right,
but then we kind of
right.
realized, oh, but to infer that we actually need to
Yeah,
have knowledge of
right. So
orientation of the
this is
parent
to me, this
object.
was a clarity. It's like, oh no, now I got it. It's like it's a child, and the child, it's just its relationship to the parent. That's all we're talking about. Okay,
Yeah.
so it's
Yeah,
not
maybe
part
I
of the
just
problem. It's part of the solution, I think.
right. Yeah. This is the main problem that
Right.
like there can be many behaviors on an object in different locations, and if we just have one global state for the whole object, that there would be kind of a combinatorial explosion of like capturing all the different
Yeah.
combinations of the behavioral states. And so just very briefly, just so the visualizations are familiar, basically the proposed solution for that was to just that we say, okay, well, we don't want to have this combinatorial explosion, so let's not have state in morphological models. And state is only defined in behavior models. And so that means we don't have a state representation here in the morphology models, and we wouldn't have the kind of time input there either. Um, and then,
By the way,
yeah, basically,
you argued that time might be beneficial in morphology models, and I think that's possible too. So it wasn't like we had to get rid of time in the morphology models. And so that's possible. We just didn't really come up with a good use case
I
for it.
Yeah, I guess it's just hard to think of how it would be used if there wasn't state, but maybe there's a
right.
way.
Yeah, I
Well,
think
I mean,
I would definitely argue that time is useful, but yeah, if there was no
time
state,
itself is this time itself is the state, right? I mean, it's a type of state. You can say, well, this time it's this, and this time something else, something. Well, we don't have to argue about it. I'm just saying there wasn't like a hard that said, hey, time isn't available to morphology models. It's there. It might be useful. And I'd also, yeah, I disagree with your assessment here that there's no universal algorithm. I think it still is. Um, the only difference really is that behavioral models always exist through time, and we had that before. That
yeah, that's what
behavioral
I said
models,
here. Like instead,
yeah,
state and time are extra mechanisms that only exist in behavior columns.
right. But that was in our previous solution too, right? Behavioral models always had time.
Well, in the previous one, it was like they were exactly the same. Both of them received time or context input and had a state representation. And the only difference was the input, that it's static features versus changing
Right.
features.
All right.
And
Well,
and I
we'll
yeah,
agree to
and
disagree
for
here. I don't think it's a big difference, and I don't like the idea of saying there's no universal algorithm. I think it's very, very universal. But
I
yeah,
mean, and
one
just
has
for
time.
clarity, I thought with the behaviors that you've argued that it wouldn't necessarily always be time because some behaviors don't
Yeah,
follow like a prescribed like it's
right.
more the kind of causal context like
Yeah,
No,
um
that's why.
there's always sequence, right? Right? We have to be careful. So
yeah, but not
not
necessarily
Right.
timing,
like a
not
like
timing doesn't
not
right.
time cells.
What I meant is that the behavioral model unfolds over time. That is
Yeah,
that
right.
it has
But in terms of
multiple.
the time representation coming in,
No, right. That's
that's
not
not necessarily
universal.
for all of
Not
them.
always.
Yeah.
Not all of them. So we're careful in our language here because sometimes I use time to mean specific timing, and sometimes I use time like, hey, it flows through time. It's a sequence.
Yeah.
Uh,
And yeah, that's why I added like time slash context because it could also be like action condition, for example, like the stapler only opens when you apply a certain action to it.
Right,
Just time passing won't make it open.
right.
Um,
But the key item is the behavioral model has states that don't exist at the same time. Whereas what I was arguing last week is a morphology model would be a union of its different observed positions. And so one only unfolds in sequence and the other doesn't have a sequence.
Yeah, so yeah, that's what I drew here now in the next figure. So
Yeah.
both, like in the previous version, both morphology and behavior models would have states, and in morphology models, the state could represent different static configurations the object can take on. So basically, when the stapler is open, you learn one morphological model. It moves, you learn various behavior states. It stops moving, you start learning another morphology state again. Versus here in this proposal, behavior model looks exactly the same, but morphology model is basically, yeah, a union of possible features at locations. Or like at one location, there might be several different potential features.
Yes, it's on a location by location basis.
Yeah.
I have a question on this.
Yeah.
So my understanding after listening to Jeff's presentation last week, so I agree on the behavioral states for the left, that with the three arrows for each state, and that each arrow is representing a change in feature at that location. But for the behavior, my understanding of the behavioral state was that it acts not on the like features, but on the child object.
Right,
like it
right,
represents that arrow is not representing change in features at object, but
right.
it should be maybe like it's maybe like a nitpick, but maybe it should just be like one arrow
No,
per state.
no, right. No, it's not a nitpick at all, Jay. It's an important distinction. I'm not sure if we're reading too much into the figure, but I think when these
Right.
figures were originally drawn, we were suggesting, oh, you observe these movement vectors at each location, and we concluded that that wasn't going to work. And so Vivian had the idea of doing sort of the, whole object movement vector, and we talked about
Yeah.
that last week. So I think that's not reflected in this picture per se. This
Right.
picture
Yeah, I
sort
was
of,
thinking about whether I should show that, but then I thought this would be a bit clearer because, like, if I just drew one arrow, that doesn't
Hmm.
show that this flow is expected to be at at all of these locations. Like,
Yeah.
right, right,
that's
right,
the
right.
size of the object that's moving. So I just wanted to keep the figure as kind of similar as before, because like that proposal is independent of these two contrasts. Like it would look exactly the same
Mm.
here and here. Like that was a separate new idea.
But by the way,
Okay.
just an aside, the last 2 days I've been puzzling over this, because I really want to deeply understand the implications of like doing this single vector movement for the child object, and I haven't quite. I'm confused, but I mean not confused. I just I don't understand it completely yet. So maybe if at the end of the day we have more time, we could talk about that.
Yeah. Yeah, I just didn't want to go into
All
that
right,
separate
but it's a
topic
good
here.
right, but it's a good
But yeah,
observation, Jose. Those are not individual areas. It's the whole
yeah.
object.
But so yeah, just to kind of show it a bit differently, the way that previously we were thinking about how this would function with states and morphology models is that it's still like all states are in the same reference, like the locations for each state are still in the same reference frame. There's one reference frame for the whole object. And then similar to how like object ID can condition which features to expect at what location, the state ID can do the same. So if I'm in state one, that would condition to expect those features at these locations. If I'm in state two, I would expect the yellow features at the yellow locations. And so when the state is unknown, there are multiple possible features at one location, same as here. Like if we don't know which state we're in both cases, if we look, I don't know, here, we could be not on the stapler or we could be on the stapler. We don't know which state it is in. Once we know the state, then all features can be predicted at all locations in this case, and the state can be inferred without a behavior model. So just the morphology model on its own can infer the state, same as it can infer object ID, same mechanism. And the location by location connectivity is local to the column. So defining which features to expect at what locations are these kind of within column connections between the state representation and the expected features. And then here in this proposal, since there's no state in morphology models, we have to rely more on the states in the behavior models. And so the behavioral states are associated with the different locations on the morphology model. And so we have these kind of location by location associations between locations in the behavior model state and locations in the morphology model. And so, yeah, that means we always need the behavior model to infer the state. We always need to activate that. And we need behavior model input to the morphology model to make predictions about which features to expect at what locations. And this kind of location by location connectivity is now between two columns, or at least, yeah, if we have behavior and morphology models in separate columns. And it also
it's a standard child parent relationship.
not
Basic.
really, because the way
Well,
we
it
talked
had
about it in Milan is that it would actually require more like
the
layer
layer
4
four,
to layer
yeah,
4
right.
connectivity.
But
Like,
the kind of establishing those connections, right? It would be different in that regard. But other than that, it's like you're connecting locations and locations on the parent and child object. Yeah.
right, yeah. It would be like, yeah, similar to how the feedback connections learn like location by location associations. Yeah, we would do the same here. It
Yeah.
would just be that both feed forward and feedback connections would need to be driving input and activate specific features and locations. And so that makes it a kind of a tight coupling between behavior and morphology models. And yeah, another kind of open question around that was like, how does this then generalize to new combination, like never before seen combinations of behavior and morphology models? Yeah, just to clarify, both of them require location by location associations. It's
Yeah.
just a difference of where these connections would have to be learned.
So I'll let you go on, but I want to point out there's a lot of stuff on the left that would be red too. So it's don't make it sound the left side was all hunky dory. I mean, we had no idea when we would create new states and when we wouldn't create new states.
Yeah,
And
that's the
you know,
big that's the big question
all right.
of
I'm just going to point out
questioning
that
this.
if you look at this, like
But
all the red problems are on the right, there's nothing on the left. No, that's not true. There's a lot of
well,
stuff on the left.
yeah, the problem exists on the left. But what other red things are on the left?
Well, there's the red things of right, but those are real. Okay, if you want to call those the problems, like how do you decide how many different states that you're going to represent in this object? How do you decide which one you're dealing with at that time? When you start to begin one, end
Yeah.
one, some states are continuous and not continuous. There's a way of learning. It's not enough time to learn the thing on the left. There's a whole bunch of issues that are practical. I don't want
Yeah,
to
so
nitpick
that's
them because
the
I just don't want you to be making it seem like, oh, this is like no. The problem on the left had a lot of problems too.
well, yeah,
So
that's the thing that I just mentioned, like how can they help
all
capture
right. I'm
state
just saying,
variables, when would we learn a new
right.
state? So yeah, that's why I
All right.
started here saying, okay, there is this problem with
Okay.
the previous approach.
I'm just
And
you're just pointing out all the things in red are the issues that need to be resolved, but it doesn't. I don't see them below, so I just wanted to point out that there's a lot of red on the left too. Someone looking at this say,
well,
"Oh my God, well the problem on the left has no problems." I got it. I see what you're saying, but
but
it has.
yeah, but nothing besides these that we're trying to address, right?
I don't know. Let's not worry about it.
Okay.
I
Yeah,
think some of the things are. I think
maybe
some of the things on the right
the
are
thing
real
about
easy.
the child, the other side quest you had, that might be worth just putting there, just so we don't
Yeah.
extract it.
Yeah.
Yeah, and that one is
Yeah, that
also,
one.
I guess, for both.
Yeah. So I view the car example as a fundamental problem that you can't work around. And I think all the ones on the right here are pretty easy ones. But maybe I'm wrong about that.
Yeah,
But
I'll
it
get
doesn't
to
matter.
the alternative
Let's get you
in a
alternative
moment.
soon. Yeah.
But just to complete the picture, in the one on the previous version, we said that we could learn associative connections between behavior and morphology states. So we could, yeah, associate the open stapler with starting the sequence of uh, closing, and vice versa. And yeah, those associative connections can be leveraged to accomplish goals. And then we can also learn the kind of standard feed-forward and feedback connections, so we can assign the behavioral states as child objects on locations on the stapler and have the feedback connections. So the behavior ID and state can be associated at multiple locations in the morphology model, and locations in the morphology model can predict locations in the behavior model as well. But just to note that isn't necessary for recognizing morphology or behavior and their states. We can still do those two things independently, even if the morphology and behavior combination was never observed. And yeah, learning these feed-forward and feedback connections basically speeds up inference, and it helps to predict the behavior when you just observe a static object, and to bias which morphology to expect when you observe a behavior. And yeah, basically back some months ago, we kind of had this big list of requirements, and it met all, like that solution met all of the requirements that we had. And then, yeah, I don't have to go through all this. Basically, there were just some remaining questions also about how this now relates to achieving goals and specifying goals. But maybe I'll just talk about the potential alternate solution, which I think is a bit of a mix of both. And it might be, like, in my mind, it's like a necessary change to the old solution, definitely, because we have that problem. We need to solve that problem with the car. But it's kind of saying, like, let's not throw out the baby with the bathwater and keep states and morphology models, but maybe there's a different way to solve it. And so, yeah, just to kind of recap, some of the questions were, how can state and morphology models be defined and learned? When would we learn a new state? And how would we avoid a combinatorial explosion? And so this kind of alternate solution builds a bit on some ideas we discussed various weeks ago about classes of objects, and learning differences between an existing model. And it's also kind of nice because it avoids, like, if we talked about keyframes before, we often kind of thought, okay, well, then we have to relearn all the points on the stapler again. We don't really want to have to do that. And so this solution also gets around that problem, and basically like reusing the parts that didn't change and only learning the parts that change. And so basically the idea would be that you learn the state 0 or object ID. You could just call it object ID, which basically learns the object in its first configuration when it's encountered, like the open stapler standing on your desk. And then when you see a new configuration, or when you observe features that are not correctly predicted by that model, there's a new state, but that state only stores the things that are different from the default configuration. So the closed one would only store these locations here that are different. If now the plate down here rotates, state 2 of the rotated plate would only store something at this location. It wouldn't express anything about the rest of the stapler. And so basically all predictions would work like, if I'm on object O in state S at location X, predict feature Y. So far without a state, it would have read like, if I'm on object O at location X, predict Y. So it's basically just adding the state conditioning the same way we talked about it before. But now the thing would be that there's kind of a default state, or just the object ID, that predicts feature set locations, and all other states encode differences from the default. And so if S0 already stores a feature at that location, the other states override or inhibit the prediction. And then multiple states can be active at the same time. That's kind of the key thing. So the stapler can be closed and have the deflection plate rotated. And so in that case, all three of them would be active.
Are those three separate variables? What are they?
So they would be SDRs in layer 2, 3, and it would just be a union of SDRs that is active. And yeah, it doesn't require relearning information that hasn't changed between states and default. And so I think, yeah, it's quite powerful because using just unions of state IDs in layer 2-3, you could express all the different combinations of variations without having to learn separate states for them. And you can communicate up unions. You can invoke unions as a goal state if you wanted to. But yeah, just to kind of wrap up learning and inference. So for learning, one potential way to say that a new state should be created is that when the object ID is active, but new features at locations appear, then that doesn't match with our current model, so it must be a different state of the object. And observing a behavior could help maintain the object ID to trigger a new state creation. So basically say, okay, this is still the same object.
The earlier point, the new state is created when an object is active, but there'll be lots of places where there'll be new features, and you don't know if they're all part of the same behavioral state or not. You know, I look at the stapler and the top's down and the plate is rotated. Those are both novel features, but they're unrelated. They're not in the same. They shouldn't be in the same state. I think there's an issue there.
I mean, the idea would be you don't just learn a stapler and then you look away and then you look back and everything has changed about it. I think it would be quite difficult to say, oh, this is still the same object. It's more like you look at the stapler and then you see it opening, and then you look at the stapler and you see the deflection plate turn.
Well, you know, I could be looking. I don't know. I think it's a general. I think the criticism, really, the point I'm making is still valid. A car, you know, multiple things can be moving, and just by saying something is different than it was before, it isn't sufficient to say that a new state needs to be created. And when the stapler arm is the stapler arm is
well,
moving,
like different and kind of not predicted by your current representation.
Yeah, but there's lots of this. My point is, there's lots of things that could. The set of things which could be different is quite large, and it crosses across states, different types of states.
If a lot of multiple behaviors are happening at once, would you expect to be learning them at the same time? I thought you would kind of pay attention to them individually.
Well, but it doesn't have to be. The changes don't have to be happening at once. It's just that there has to be different than the last time I saw it. So if I looked at the stapler and the last time I saw it, the anvil's in one position, and now I come back and the top's in a different position, the anvil moved, I'd have no idea of whether those two changes are related or not. The point was we only do this when we see something. The idea was the only creating a new state is really going to be important of detecting motion of a child object. And if you don't detect motion, this is just a morphology state we're looking at here. Without knowledge about what's moving, it's not that something is different. We have to see it changing.
That's what I meant with the second point here, that observing a behavior can kind of help maintain the object ID and trigger the new state creation.
Well, I guess the first point is insufficient. A new state is created when an object is active with null features. Right? That's not sufficient.
I agree. That's why I said you also need to see the change happening to know, okay, this is still the same object, but in a different state now.
Yeah, I still think it's problematic, but I will keep going.
Okay.
Yeah.
Can for point number 3 in the section above, where it says all other states encode difference from the default, does that mean that for S1, that we are learning both that there's features of the stapler top in the close, like the yellow, and that these don't exist in the up position? Like when we say we're encoding a difference.
I actually drew this wrong. These arrows should point here. So basically, we would learn that
both those features up there don't exist
not
anymore.
Exist up here.
Okay.
So inhibiting the prediction of the default model here.
Okay.
But then that feature should now exist at these locations here.
I see. Okay.
Which
sounds like
it might be expensive, but actually, if you compare that to learning all the different keyframes,
Right.
It's
Yeah.
better.
Yeah. Compared to learning all the different keyframes, yeah, but okay. All right. Sounds good. Yeah, that clarifies my question. Thanks.
Okay, yeah, sorry.
It's
Yeah.
it's uh,
Messed that
it's
up.
also it's bothersome to me that there's a concept of like the default state, and then the others are encoding differences from the default state. It's an
I
asymmetry
mean,
that
that's just
is, well,
that basically just the way you encounter the object for the first time or the way you encounter it most of the times. It doesn't really matter what you set as the default. Any of these could be the default, that like the deflection plate could
I
be in
I
this way in the default. Like
I'm
it
just
for the
seeing. I
mechanism,
got
it
it.
doesn't matter which one it is.
I know, but okay. I see numerous problems here, but let's keep going. I mean, the idea of having a union of IDs is not. I like that's a general idea. Like, oh, because it's a property we have, we know we can do unions. Having a union of IDs as a mechanism is a comfortable mechanism. But here it's like, oh, one of these IDs represent the entire object. These other ones represent only changes. How do I know that? When you do a union of SDRs, they're all equal. There's no way of differentiating them. And so one's representing the entire object, and the others are representing only parts of the object. And if I'm and
It
if I'm in
doesn't.
some state, and then I start observing the other parts of the object, wouldn't I be doing simple pooling into that state and learning the entire object again in that state? Why wouldn't it do that? It seems like it would do that.
I
Sort of,
mean, it doesn't need to know which one is the default state and which one
but
isn't.
no,
Like,
but my point is that these states are different. There's supposedly some are only
mm,
representing parts of the object, and the one's representing the entire object. And so that's a problem that the neurons wouldn't know that, and they wouldn't,
well,
I mean,
so
is it
if
is
I'm
it
in the
it's
more in some ways it would it feels like it would what would ended up happening is like some are just representing the kind of stable parts of the object. So that might just be the base.
but
Like
how
that
does it
might
know
almost
that? So
be
maybe the stapler
just
is in the yellow, the
like
stapler is in the yellow position now, right? And I'm observing, oh,
yeah.
these are different. So I'm gonna create a new S1. But now I in its closed position, I start looking at the base of the stapler. Why wouldn't I be learning those features too? I know they're not different, but it just the general rule of the system's always going to be trying to learn what it observes at some location. It's going to be hard for
right.
it to
So
say, it's like, oh no, don't learn that now because that didn't change from before. But how does it know that? I
no,
mean,
yeah, because you're predicting it correctly. So basically, the only reason why state zero is the whole object is because first time you observe it, you look everywhere on the object, you learn a model, and then you see something has you see a behavior happening, like the stapler closed,
so
and
here's
then
a,
you
I,
try to
I,
keep using your same model to make predictions. When the
so
predictions
often
are
what we
correct, you
do,
don't store anything,
but
and when
what
they're
we do
wrong,
is we see an object, we learn a model of it, and then we continue to refine that model. We learn new features about it. We pay attention to details we didn't see before. Well, those are things I didn't predict because I didn't pay attention to those features before. And now I
yeah,
see them, and so my model doesn't predict them.
yeah.
The general what we want to do is you just want to add that to our model. You don't want to say that's a change.
Well, yeah,
I
we're just
didn't,
adding it to the model and associating it with a new state.
but it's not associated with a new state. I'm giving taking um an object which I haven't learned all the details, which is true of almost every object, and I can then notice new details on it that I didn't see before because I'm attending to them, and then I say, oh, I didn't predict that. There's a feature here that I didn't predict. Well, it's because I never learned it. It's not because it wasn't there. I just never learned it. And so now I see it. How do I know that that's? I don't know. There's no way I could know that feature appeared and it's
But I
part of a
mean,
state, or if it just was there all along, I didn't know it.
in that case, you would just not make a prediction if you hadn't learned that part.
No,
But if you
well,
had learned something at that location, you would make a prediction, but then
no,
that
right,
prediction
right.
was
Well, look,
wrong.
listen now. So I didn't predict that the stapler top would be in some position because I never saw it before. But now I see it there. I want to associate that with a new state, but it's just I had a prediction of nothing, and now there's something there. That's exactly
Yeah.
the same as what I was just referring to. You could have a prediction of nothing, and now something's there. In one case, nothing's changed at all. You just never observed that location before. You don't know that. And then in the other case, um, you didn't observe that location before either, but now there's something there because of a movement. I mean, how am I supposed to know one was caused by a behavior and one was just because I didn't observe that location before? And even if I see
Well,
there's
yeah,
a
I mean, that's a kind of separate problem we have in general with our models, that we can't distinguish between we've never seen this location before and we know that nothing should be there. That's a general
right.
problem we haven't solved yet. Like that's
So
not specific
so
to this.
so so I think this. I don't know all the issues with that problem, but in one of the beauty of the things I proposed is that a learning model just learns the same way all the time. It just says if I see a feature at some location, I'm going to add it to my model. That's it. That's all it does. It says if I see a feature there, I'm going to add it. Now there's an additional thing of if
But
we
I
see
mean,
a.
it learns in association with these states here. It's the same thing.
I'm not sure what you mean.
Like you lay
Um,
down points here and then you associate it with states in the behavior model.
right. Because the behavior model, because we detected change, we have a behavior model. So it's all a matter of detecting change. Um,
Yeah,
so
and here we're also detecting change from what we learned before.
no, detecting change like it changed in front of me, right that moment, something changed and my attention is drawn to it. So it's not something as different change. It's something changed as I'm observing this thing. That's the definition of a behavioral model. Something changed in front of my eyes. It's not just there's a different state of the system. Behavioral models are change detectors. I mean, like dynamic change detectors. This moment, not like it happened to go.
Yeah,
Um,
but then by our definition of morphology model, while change is detected, we're not getting input to the morphology models.
I'm saying you lost me on that one.
Like we wouldn't get static input if currently changes are being detected.
Uh, right, but the point was when a change happens, um, we start a behavior model, and as soon as I can observe a feature, it is associated with that behavior model. I don't think these are equivalent. I think this is what I viewed as the proposal I made. I think it was super elegant in regards to that model. The morphology model didn't care at all about the models themselves just kept adding features. They would detect when something was different, like it'd say, "Hey, something's different," but it would just keep adding it. It wouldn't have to distinguish with a state or
Yeah, but
non-state
it
or anything
has
like
to
that.
associate with states as well, but just states that are in the behavior
The
model.
the 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 way I think about it is in the morphology model, the observed feature is a state. You observe a feature, it's a state of that feature. It turns out most features, if they don't have any behaviors, there's only one state. It's in this state. That's the way it is. But but now if I have two features at the same location, or just a feature that isn't always at some location, then that feature is itself the state of that child object because it tells you that, oh, the state position is in the mid position, or the switch is in the up or the down. It, the very definition of the fact that um, if you have two features stored at some location, um, that it becomes that by definition, those are states of that feature. There's nothing else to learn. There are no states. The states are inherent to the features themselves. If I see a feature, it's either that feature is always part of a state. It could be just a state of a feature that never changes, but it could be also a state of a feature that does change. It's so
But the
simple.
issue is if you don't have a more global state like what we have here in the behavior model, I mean, the main reason why this kind of works to keep making other predictions about other locations is because there's a global state in the behavior model and we learn the associations. If we just have these local feature states, then seeing one doesn't tell you anything about what you should expect if you move
Right.
your eyes here.
So we have to rely on the fact that we have a behavioral model and a child object model, and those together tell you what to predict. Right. It's
Right.
not
So I just don't see the difference
the
between learning the
we're just
associations here.
I'm just talking about learning in the morphology model is so much simpler. It's and there is a state. The state is the feature that you've stored at the location. That is the state. There's no separate need for another state. It's all
I mean,
there. It's just like
I think it's true that learning in the morphology model in the setup is simpler. I think that's true. But I don't know if it doesn't feel like an insurmountable problem to figure out how learning could work in what you're proposing,
Well,
Vivian.
I'm still struggling with what's the advantage of it because it
Yeah,
feels
maybe it
so
helps if I go through the rest and kind of another example.
right. But I
But yeah,
immediately
Jose,
I'm seeing
Yeah.
problems with this already. You know, I'm saying, oh my God, how are you going to know these different states? And the states are not equal, and some is the whole object, some are partial objects,
they are
and
equal.
no, like the blue one is the entire object, and the orange
No,
one
Well,
that's
I,
being
I
just,
like,
I
I
actually,
mean, if state three would be like everything, if all the locations on the stapler have changed, then that would also be the entire object. It's just what has changed.
yeah, like it almost feels like what would eventually happen is like actually the stapler arm in the sort of default position would also be a default state, a new state, sorry, and the state zero would only be the bottom, or like if you because that might also be more efficient than trying to inhibit, um, that like removes even more the kind of specialness. Like basically the S zero just stores everything that's never changed. Anything that
Yeah.
has changed would be represented by a different state.
Yeah. And I mean, it's basically just each of these predicts some features at some locations. And with the union of them, you can predict the combinations of those. But it's not saying that one has to specifically store all of them or the other ones can only be about specific parts of the object. I mean, if you have an object where you have like a more global movement, like a wave, then each state would store. I mean, maybe wave is a bad example because it's a very continuous change, and that would probably just be a behavior model. But like there are two states, and like the scissors, I guess, maybe are a good example. When they're open, that's one state. When they're closed, all of the locations have changed. So it's again representing the whole pair of scissors. They're just two states. They're not like in one you have one you have the other. Maybe just the middle part that it rotates around is the same, but um, yeah,
I don't think it's going to work, but well, let's keep going.
yeah,
Yeah.
Jose.
Um, the question about trying to learn states. Um, so if we're trying to learn S1, the close figure, like I understand that in storage, it's storing that on the we're not going to predict any features at the top portion. Let me see if I can annotate or like, is there like a laser pointer or something? Yeah, so we're gonna store that nothing exists here, and then we're gonna say that like things exist here. So I understand that in storage, this is sparse or like efficient, like we're only storing the change, as you say. But we still need to visit every other like location to make sure that nothing has changed. Is that right? Like if I
Um,
want to learn S1 and like ultimately
yeah,
like
I
we
mean,
might visit here and be like, oh, like it's not different from S0, so we're not going to store it, but we still need to go to that location to check. 'Cause,
yeah, I
yeah.
mean, you can probably use these kind of heuristics, like you pay attention to where movement is happening. Like if you observe the stapler closing, you look at the places where the change just happened, and don't expect anything else to have changed where you didn't detect any movement. But yeah, technically, if you don't look here, you don't know if anything has changed here as well.
Right, which
Got it.
isn't like a failure mode because like let's say when you lift the thing, the anchor plate thing moves, and you weren't paying attention to that. That's like then it's reasonable that you wouldn't have a model of that changing. Um,
Yeah,
Okay.
and then yeah, and obviously by using like child object IDs, that would be like it'd be sufficient to see part of the top moving to infer that the whole top is moving.
yeah.
Um,
Yeah. I guess the thing is that, well, yeah, then that means that for every new state, we still need to like visit all parts of the object, which, okay. Um,
Well, you have to
well,
do
I think
that
that's
in
true for
any
pretty much
case. Like
anything.
if
Yeah.
you don't look at a location, you don't know what happened there. That's the case for all solutions.
Yeah.
Right.
Yeah, maybe we'll go to Rami and then continue on.
Yeah, just
Yeah.
a question. So are these states unique to the object, or are they applied to any object? Are they learned independently as a difference, kind of like we're learning the behavior and applying it to different objects, or are they like unique to the object? So like a similar difference would be able to apply to different objects that exhibit kind of like the same behavior.
Yeah, the idea would be that they're unique to the object because it's all within the same object's reference frame.
But S1 and S2 have to be completely separate, unique SDRs, right? And the three up there.
Yeah, yeah,
So
right. These would be two different SDRs,
so
but
basically you have three SDRs up there. Each one's unique to the object.
yeah,
But two of them are only representing subsets of the object.
in this case, yeah.
I think viewing them as subsets is, I think it's easier if you just think of it like everyone just predicts some features given the current reference frame.
Yeah.
The first time you learned an object, you saw all these parts of the stapler. Whatever the SDR that was active in L2, L3 was predicting, it was seeing like, okay, the bottom, whatever, and so it's predicting that. But then later you're in the same reference frame, but now you're seeing different features. So there's going to be a different SDR that's going to help you predict those.
But the different SDR, remember the SDR is unique to the reference frame. So I have to have three SDRs now that are unique to this object. Right? I mean,
Yeah.
they have to be three separate representations of this object. But
Yeah,
then,
I mean, it
but
doesn't
then
seem
I have to switch
impossible.
back and forth constantly about when I'm pooling into those three different SDRs. I have to switch back and forth which one I'm using at this point in time, because this is a pooling operation, right? So,
well, and that's what the behavioral state would help with, in the same way it helps in learning. I think in the
well, I don't
alternative
know.
model, right? That whatever.
This picture doesn't show me that. This picture just says I got
Yeah,
three
let
SDRs
me,
representing this object.
okay, yeah, maybe it helps if I talk a bit about inference now. So basically, initially, when we haven't looked at anything yet, all states are possible. So union of all these three states would be active, and we'd be predicting multiple possible features.
Wait. Stop right there.
Yeah,
Initially, we haven't observed anything yet,
yeah.
right? So there aren't three states up there. There's no union, right?
No,
We haven't
all
observed.
states could be possible. Same as we have a union of possible objects active.
Oh, I see. You're just saying during inference. I see.
Yeah,
Got it.
inference.
Okay.
So we don't know what we're sensing yet. We don't know which state is in. Same way
Well, there's no
as
union.
here. Same way as here.
There's no
They must-
union until you wait a second. There's no union until you start observing something, right? There's no
Yeah. Assume we've
hypothesis
seen
into.
something that's
Well,
consistent
what
with
are we seeing?
stapler.
What are we seeing? Well, I don't know. What it says all union. I wouldn't have a union. If I saw the blue parts of the stapler, I would just have the one. I would have the one SDR. There would be no. The other two would not be invoked at all.
Well, why couldn't the
I
reference
mean,
frame invoke all of them?
Why would
yeah.
it? There's the only thing that's going to invoke
If
the
that reference
orange and the
frame is
green.
a possible object,
No.
then
The temporal pooler basically says if you give me an SDR, which is in the column, right? It can map into that could map into me, and so I would only invoke the orange SDR if I observe the orange part, and I would only invoke the green SDR if I observe the green part. I'm not going to invoke those unless I observe those specific features. That's how temporal pooling works, right? It's like you got to observe something and say that invokes this thing. I mean, if I didn't observe it, I'm not going. Why would I? There's no reason to invoke this. Those SDRs aren't going to get invoked. There's nothing leading into them.
Well, I thought it's like, I mean, when you observe uncertainty, there are many possible next predictions when you move somewhere. Same as if we don't know which object we're on, we have a union of possible objects.
Right. So
and
the
you can
only
make
reason,
you
the
can make
only
several
reason,
different predictions based on those.
so the only reason you get a prediction is you've observed some features that are consistent with that prediction, right? And with that ID. So at the point where I've only observed the blue parts of the object, there's been no data to suggest that the S1 orange SDR should be invoked. There's nothing that's going to invoke that. It has to observe. It's a pooling over orange states. So if I haven't observed a yellow or orange state, then not going to happen.
But then maybe is
Well-
it fair to say then the proposal is that we're going to use SDRs in S2 L23 as because it's going to be conditioning what we might see. It would be invoked by the reference frame, and then
Yeah.
it's going to become sparser
Yeah,
Okay,
it
over time.
sparsifies as you see more.
Well, we don't have that today. I mean, that's not how we imagine it works. It could work that way. That's something different.
Yeah, because I guess it's a little different because it will like immediately drive those the SDR such that
I mean,
and we kind of need that driving, like we need those cells to be active in order for them to predict cells in L4. If they're not
well,
spiking, then they
that's
can't predict cells in L4. I'm just trying to think through how it would work.
yeah, I'm trying to think through it too. I'm having trouble getting it to work.
I mean,
Maybe,
yeah, I'm
maybe
thinking
able
of
to
it
think
as
about it more.
the same way as when we have multiple possible objects, we make multiple possible predictions. And then as we see more features, we have less possible objects until we only
Right,
have
but
one.
right,
And the same way here, we have multiple possible states. So we make multiple predictions, same way as in both of these.
when we
And
have multiple objects, there's support for each of those objects. That's why you'd have a union. There is supporting evidence for each one. If there wasn't a supporting evidence for one of those objects, it wouldn't be part of the union. In this
But they're
case,
supporting in the sense that this reference frame is supported.
well, that's a different.
We think we're on the stapler,
This is a new,
so
totally
it could
new
be in
idea
different
here.
states.
This is a totally new idea that you're proposing here. This is not our temporal puller. This is the temporal puller says, I'm going to get invoked if I see evidence from me. The evidence isn't, I'm always invoked. It's like you're putting the cart in front of the horse, I guess. I mean, if there's no evidence for the S1, how am I going to learn? How's it going to get invoked? Who's going to invoke it?
So,
It's like,
well, okay, well then, but that's how it is at Monty. Like in the beginning, all objects are possible. And then only as you start observing more features in more locations, that narrows down.
I mean, yeah,
okay, well,
technically that's true, I guess, because the features are really ambiguous in Monty. So like all reference frames become invoked as possible. In theory, I guess if we had
but
if we
that
had
can't
features that
happen.
were more unique or something, then you would have objects that
Right,
were
right.
like, well, I don't
But
have any features that match this.
we can do that in a computer. The neurons can't do that. There's a limit to how many things you can form a union of. And if you try to form a union too many things, then all the cells become active and it becomes useless. It no longer is separable. Right. So it doesn't work like that in biology. So maybe that's why we're thinking about this differently. So yeah, you can't these are all co-located in the same set of cells here, and you can't just, I don't know. Anyway, it's not how we've thought about temporal pulling. It's a different, and we've never thought about temporal pulling the ID being invoked by the reference frame. It's so like that's just never been how we thought about it. I mean, I'd have to think a lot. It's like a completely different mechanism for temporal pulling. I never thought of it, so that would be hard to think about. That's a major change of how we think about it. I still think this idea that you have these three STRs up here, or many STRs up here, and they're not co-equal. And I think this is problematic, at least in neurons. Maybe you can
But
make
they
it work.
are equal.
No, they're not, because some are representing the whole object and some are representing part of the object.
But it's not prescribed which ones
Well, you
do
said
that.
the default state is the blue one.
In
So
this
we eliminate-
case, I mean, it could be the
Right,
green
but
one.
but the green one and the yellow one don't represent the entire stapler. They
But
only
that's
represent changes of the stapler, so they're not equal. One is an object ID and the other are sort of behavioral state IDs. They're not equal, they're just different.
But I
One's
mean,
representing
does the scissors example make sense to you? Where like
you
both
have to go
states
through it
represent
again.
the whole-
You have to go through that again. I didn't follow that one.
where like with the scissors opening and closing, all of the locations have changed between the two states, so both states represent the whole object.
That's
There's
not
no,
clear to me. Well, it's not clear to me how we'd represent the scissors, whether all states are changing. I mean, this is the same we talked about with the stapler. What if the bottom moves down and the top stays the same, right? It's the same idea. It doesn't seem like we see it that way. I mean, it does feel like we have, an object anchored in a reference frame, and then some parts start moving. If all parts start moving, that's an interesting question. Um, does does everything moving through the reference frame? And maybe, I don't know, or do we say, the bulk of it's still the same, and or does then if you start seeing the top and the bottom of stapler move this maybe like the scissors, then you could say, well, um, all the features, all the children of this object are changing. That's a little bit like a transformer, right? A transformer, every feature changes. A transformer toy. Um, all the features change.
yeah.
Yeah. So I don't know. I think that's the scissor example is just like this bottom of the stapler moving. I'm not worried about that. I don't see
Yeah, or
a
maybe the
problem with it.
transformer toy is a better example. But basically, if all the features change, then the other states also represent the entire object.
I,
Uh,
I had a quick comment about that, but can we let Rami speak? Yeah.
Yeah, just a clarifying question. Are you thinking of the states as being represented separately in like layer 2 and then the object in layer 3, and there's some association between them such that if we have like an object ID that like we infer an object ID, then that means multiple states are being like activated as a union. So it's like a many to one association. Um,
Um,
or are they like part of the object ID in layer 3?
yeah, I don't really have a strong opinion or didn't think it through that
well,
far. So
that's a
like that's
great.
why I put it as S0/object ID. Like in any of these are unique to the object, so any of these would tell us which reference frame to invoke
I
or
think
which object we're on. But
I mean, that's a good question, Rami, and you could just turn it into a suggestion. Um, that would make, if you wanted to go this direction, that would make a hell of a lot more sense to me. That you would have a separate state ID, um, that's a union, or maybe I'm not even saying I like this, but it's better than what you've got here, where you could have entire object ID, which is stapler, and then you can have these different like states. I think as a separate set of cells, that would make more sense to me because they're really different things you're representing there. At one point we talked about voting, and we agreed. I don't remember the details of this, but we agreed that we had to be voting on state, not just object ID. And so if you had a separate um, state SDR, that would make sense. The different columns could be voting on state. So, that's if you're taking your question into make it a suggestion, Rami.
Yeah,
Separate
so
them out.
you mean basically we have the object ID here, and then we have sub-state IDs here, and you
Those could
can
be
vote
those
on
those
ID
could
and
be a
state.
union, maybe.
Yeah.
Maybe those could be a union. Um,
Yeah, I think
but
that's definitely I think
but in this
that would
case,
work.
I
And maybe
I would
that's an
think,
advantage of this as well, is for voting that we can vote directly between these columns on state rather than
but
Yeah.
having to vote.
here's the next thing. I to me it feels like you the vast majority of times you are not going to keep multiple states of this object. You're going to determine the state by viewing it. You're gonna see, oh, we're looking at the door and the windows halfway down. Or we're looking at the stapler's anvil and it's rotated. Um, it's not like all the states of the car are going to be unioned in some place. I suppose there could be ambiguity about a particular state, like I have an observation which is consistent with two different possible behavioral states or something like that. So going along
But
Rami's
isn't that
suggestion,
what the morphology model looks like in the alternative proposal? It is just a superposition of all possible states.
Right, but it's not an SDR. I'm not, there's, the proposal I threw out had no SDR representation of states. Right, it didn't have that.
Yeah.
But I think you could keep what I said, which I still think has a huge amount of merit. I haven't been even slightly suggested otherwise, but I could be wrong. You could keep that and say, because I do remember we did conclude once that we need to vote on state, not just object ID. And the only reason we have this object ID is because, well, first of all, that's what inference is, but we needed something that columns could talk about, they could agree upon. So you could say, okay, you've got two sets of cells, one representing object ID and one representing state. But I would say that state variable is not the state of all the parts of the car. It's the state of the part of the car you're looking at. There's no point in you can't vote on all parts of the car if you're not observing all parts of the car. So, multiple columns could be observing the door or the window or the lights, but you wouldn't have a state variable that represents all partial states of the car.
I mean, I think there are advantages to representing multiple at once, like when there are correlations between the states, like the
Well,
doors
then
being
if
locked or something like that.
but then we've talked about that when there are correlations between them, if there's strong correlations, then they're not separate states. We talked about like there's like the individual windows can go up and down, but then there is a mode in many cars you can have all the windows go up and all the windows go down. Well, those are
But I mean,
separate
what's the
behaviors.
disadvantage of just keeping both of them active? I mean, if you saw the stapler is closed and now you go here and you see this is rotated, why would you not have this
Well,
keep this active? So if you move
what I
back, you
liked
can.
about Rami's suggestion was that we had identified the need to vote on states.
Yeah.
And when we're voting, we're not going to be voting on all the states of the car. We're only going to be voting
Yeah.
on the part we're observing. So if this, let's say
Okay.
the state is layer 3A. Well, I don't know, it doesn't matter. One layer is the state of the object, is the object ID, and the other is the behavioral state ID.
Yeah. Like, yeah.
Then you could vote on it. Then all the same mechanisms apply. It's not a repository for remembering all possible parts of the car. I mean, it's just like,
Yeah, I mean that's how I mean I think that fits with what I was showing, that like you can vote on object ID and you can vote on the union of state IDs,
well, I guess I'm saying,
or just one, depending on.
to me, if I was going to vote on a union of state IDs, it would be an ambiguity about a particular state, not the union of all states on the object. That's the part I think that's the part which just it doesn't work.
Yeah, I mean,
You're
I think
somehow,
I have the example of the combination lock where I think it's useful to have the union of the states, like the state of each of the locks. And so, for example, we would have the object ID that would predict almost all of the features of the lock. And then we have different states. Like for each wheel would have 10 or 9 states that are different from the default or from the object ID. And that makes a total of 28 states instead
well,
of
it's really,
1,000
it's
states
10,
if we did
it's
a
10,
common.
it's 10 each, right? 0 through 9.
Well, the 0 one is already encoded in the object ID.
Oh, I see.
So object ID, like in the default, it's 000. And so that's just what will
It
be
doesn't,
predicted if no
I
state
don't
is
think that,
active.
that's not right.
So it cuts down the needed states from 1,000 to about 30.
See, I
And
we
so
talked
then,
about we talked about Milan. I think this is the misleading problem. The way we solve this problem is it requires temporary memory. We have to go through, we have to like keep this code in our head. We have to go through each digit one at a time. We don't look at the combinations of them. It's more like I'm solving 3 separate problems. I'm solving,
I mean, somewhere you need to
real,
coordinate them.
right, but it's more like making a pot of coffee than it is a state of the object. I have 3 separate problems to solve here. I need to know the order in which those problems are solved. This is an outer loop problem. This is not something that's solved in the column. It's, we have here, what we have here, I would argue we have a parent object with 3 children. Each of the 3 children can have 10 different states. And but the solution here to solving the lock is not to have some variable which represents in the column of the lock that represents all combinations.
I
I don't
mean,
think
yeah,
that.
that's exactly what it's not. It doesn't represent all combinations. We don't have a state for each of the combinations. We have overall 30 states, and then we can have a union of those local changes. So, for example, my combination lock would
Remind me
be,
where the 30 comes from again.
so we have the overall object ID that predicts all of the black features. Then if we twist this wheel by 1, so that now a 1 is showing up, that's state 1. That's a local difference from the overall object. If we twist it 1 more, that's state 2, up to 9. Then if we twist the second one, state 10. So the next 9 states are about the second one changing, and only stores local
But
features at these local
I don't have to do it
locations.
in this order. I could do any order I want,
Sure,
right?
yeah. Doesn't matter the order.
This
But basically,
But it's more kind of location specific, which I think is the connection you're kind of trying
I
to
think
highlight, Vivian, that of what
yeah,
it's bringing from the other one.
right.
this is not a good problem. This is not a, we've talked a lot about you have to have good problems to solve things. This is not a good problem. This is an outer loop problem. It's like making a pot of coffee. We have to solve 3 separate issues here. We have to have a memory what the thing is. I have to look at it and look at each number and figure out which way it has to go. I mean, this is not, there's no, I would even argue that the model of this lock does not include any particular positions of these rings. I mean, I use a lock like this every day, and every time I look at it, I just, oh, what is it? Let me take the first one of this is, there's no state of this thing. It's like it's I don't know. I'm just going to say it again. I don't think this
Yeah,
is a good problem. We shouldn't look at this
I
one.
mean, just looking at it doesn't tell, like you don't know which numbers are going to show. Each of these states are possible. And so, I
There's
mean, I think it's
there's
a good example in the sense that it shows the problem of the combinatorial explosion. And it is an example that has kind of dependency between different behaviors on the object, which I think most objects that have multiple behaviors, those behaviors have dependencies between them. Like
no, I
the
say most of them
car.
don't. The car that they have don't. The lights are independent of the doors being open. The doors being open, independent of the windows being open up or down. The seat position is independent of all those things. Everything is
Maybe by
independent of everything
dependency,
else.
you more mean that they their states interact, not that they
Yeah.
can't change independently,
Well,
but
I just gave you
as
all
in
of
like
those. Everything I just mentioned.
the combination of the states here, or like the combination of whether, like if your windows are rolled down and your doors are open, I don't know, like those
The
can
example I
change
gave you
independently,
there.
but
I thought the examples I just gave you, none of them had any correlation with the others. None. They're just completely independent. And there's no way of looking at that.
I mean,
It's
for
just,
example, if your radio is on, you know that the key is turned in the ignition.
maybe not. My radio stays on when the car is off until I open the door. I mean, who knows?
Well,
The
yeah, you
point,
have a model of that.
my point is, we've got to solve the completely independent behavioral problem, and there has to be separate states for all those separate things. This to me is an ironclad conclusion, and you can't. And as soon as we start forming unions of them or having a single representation that represents all of them, I think we're in trouble. It's just not going to
I
work.
mean,
The
it's
beauty, what I suggested before, is that we create new states as they are observed, and there's no extra effort. It's just you observed a new feature. That feature, if it was associated with a change, it becomes
but
linked
they're
to a
still
behavior
here.
model.
You
What's
still have
that?
these. You still have a union of the behavioral states.
The union of behavioral states. I'm not. Now you just lost me. I don't know where that came from.
Like if you
We're
walked
just
around your
talking about
car
more.
and you saw
We're
all of the
talking about.
doors are open. I mean,
No, I don't. What I would do is I look at each door. I don't
yeah, but
see all
then
the doors
while you're
open.
not looking at it, you remember that they were open.
Right. There is an outer loop memory situation, right? Just like when I might remember just by chance, like when I got put my bike lock on in the morning, I vary up how I switch to lock it, right? So I have a combination, and then I wrote some. Well, I don't always lock it the same way, and I don't mix up all the rings, and so I'll typically remember later that day when I go and pick up my bike which rings did I move, so that I know which ones to move back. But that's a episodic memory. That's something I'm going to forget tomorrow. There is memory involved here, but it's really sort of episodic memory. I could say, oh, today I looked at the car and the doors are open, three of the doors are open, and this window is down. And I might remember that temporarily, but tomorrow it's going to be different. I won't remember that at all.
But to
So there's
have episodic memory, you still need to represent those states somewhere in your temporary memory.
Right. And let's talk about that. Let's go into and talk about how we integrate episodic and temporary memory with the hippocampus. And we started down that path recently where I was talking about, how you have parallel models between the cortex and the hippocampus, because these things have to be done. It feels like you can make a temporary addition to the model in the cortex. You can say temporarily, here's a new flavor of it over here, or here's some additions to it that I'm going to remember right now, but I'm going to forget later. But they're not part of the basic model. They are temporary because they're today's, the position right in this moment, or this minute, or this hour, that kind of thing. Not part of the general model of the lock or whatever. Yeah. Okay.
Yeah, I mean, I feel like this is also nice because, well, you said the wheels would have states, but I mean, earlier we said that the child object state is, you can't really define it without the parent object. So in this case, the
Well,
states would be in the parent object,
in this
and
case,
the
you might
wheel
argue
wouldn't.
even the way you've drawn it here, it tells you otherwise. You've drawn it where I see only part of the wheel, so one could argue that the object of the wheel is not a wheel floating in space. It's these three numbers in a little window, and if that's a child object, those three numbers in a window, that rounded rectangle, then it does have a state. Because the parent is the whole combination, and the numbers in the little wheel that moves inside of it is the thing.
I mean,
We
that's
did
just
this,
how it's drawn. I mean, with all the
but
other examples, like
that's
the door
also how you
opening and the
think of
switch
it.
flipping.
That's how you also think about it. It's not, so
But
we had the same issue with the light going on and off. If a light goes on and off, one could argue, well, you could say, well, we had similar problems with that. Then we could say, no, well, you could think of the light like a light bulb. So the light bulb is either on or off. And so there's a parent, and then there's an element in the light bulb which turns on or off. So I think when we get to these situations like this, what we need are principles that seem to apply. And I would say in this case, this is anyway. We can go into it again. I
I just
just
thought earlier we agreed that that's a problem, and that the child object's state needs the parent to be really defined,
right,
and so
right.
I just
Well,
thought
let's
that's
just
another
Yeah,
thing about this
and
is
we
that,
talked about some like orthogonal solutions to that, like top-down feedback, providing context and stuff.
yeah, but then so in this case the child object wouldn't have states, like the top of the stapler doesn't have states, it's just a child object, and instead its state is defined in the parent object's reference frame, so whether it's up or down.
right,
Um,
right. That's the general. We agreed that it has to be a child object. But the child object itself could have states too. So um,
it,
that's part of that issue.
it could,
I
but
think
those would be different. What like
right.
they wouldn't be states that are defined by its relation to the parent.
So if I were to try to summarize this a bit, I would say, hey, we all agree we have an object ID. That's our basic mechanism. So we're going to have that. We once concluded that we need to vote on state ID. And I like that idea. But to me, it doesn't work if the state ID is trying to represent all the states of the object at once. Then voting won't work. Nothing's going to work. You could basically say we're attending to one child at a time, or one, and we're trying to infer one section of the parent object, and we're trying to infer the state of that. And so we might have some ambiguity there. We could vote on that. That makes sense to me. But the idea that you're forming a union of all these states in an SDR, I think just doesn't work. I could spend some time trying to articulate better why it doesn't work. I just don't think it works. I also don't really understand your objections to the proposal I made last week. Because we argued about this in Milan, but I feel it's very, very clean. There's some issues we have to work through, but it felt so liberating to me. Like, oh my God, that's a beautiful idea. I mean, yet you guys feel like just the opposite. You feel like an ugly idea. Still don't understand that.
Yeah, I mean, it is like I don't see how the layer 4 to layer 4 connections
Well,
bidirectional, like
so why don't we
location
work
by
on
location
that?
between two columns for every object combination.
Well,
It just seems like a lot of requirements that we have
I'd
no
rather
idea how
work
to.
on those. What I typically like to do is I like to take an idea that just seems so solid that it's worth working on. And I felt to me this idea of how the morphology model works was so solid, that I'd want to work on it. I'd want to work through the issues. Like at one point, you even suggested, Viviane, that maybe we shouldn't be separating morphology and behavioral models. And I want to explore that again. I think that's worth exploring. That perhaps behavioral models really are a tie to particular type of children, and that you can't really completely separate a behavioral model from so even because it might be just like a generic version of the child, something like that. So there's a whole bunch of things we could explore. From my point of view, I'm looking at, I see there's issues we have to work through with the model I proposed, but none of them are at the moment strike me as impossible or daunting. But when I look at this picture in front of me here, with the union of these, I think it's impossible. I just don't think it can work. And I don't think it reflects reality. So I'm struck with, like, I don't want to spend time on it because I just don't think it's going to work.
Yeah, I mean, I said we can go back and talk about the red parts here instead. I just
Yeah.
wanted to suggest an alternative, which to me seemed much simpler and
Well, I think
yeah,
I would.
more powerful. But yeah, we don't have to.
I'll
But yeah,
concede
maybe
part of
Jose
this.
and Niels.
Let me
Yeah,
just. I can see part of. I'd like to go back to again. Rami's question turned into a suggestion. I like the idea that adding a separate state ID that works like a temporal pooling ID, and that state ID would get voted on between columns, in
isn't
addition
that
to
what
the
we
object.
had the whole time? Object ID and
I'm
state
just
ID, and
saying
we vote
it's
on them.
right, but we never got state ID to work. Right, we never got state
Well,
ID to work.
I mean, that was the
So
kind of the
all right, so I'm
description
going
we
to go
wrote
back.
up in
Let's
the
go back
documentation and
and
everything.
let's not throw away state ID. I think so. Maybe that's what I'm
Yeah, I
just saying.
agree. I want to. Yeah,
All
I
right,
want to have
but
state ID.
state ID to me cannot represent the state of the entire object. It has to represent the state of the thing you're observing at that point in time, and it's a part of the entire object. That to me seems very, very almost certain that the columns are going to vote on the state of the window, the state of the lights, the state of the stapler top, not there's
Yeah,
no
I mean, that's how
communication.
we wrote it up in the documentation and everything, that will include state in the votes and in the messages passed up the
Right.
hierarchy.
But we need
That
a
will
way,
become
a
part
different
of
way,
that
but we
message.
didn't have a way of representing, we didn't understand what state was. And I argued that state can't represent the entire object. And yet I don't think there's a default. There's not a master state and minor states. So as long as we say that the state is on a behavioral basis, or a child object by child object basis, then that works.
Okay, well, yeah, I
But
thought that this was kind of that mix where the state is on a kind of location by location, like a local
no, but
basis and not a global state of the
everything you described
object.
today was that S1 and S2 are joined together in a union. And that I
Yeah,
say, that doesn't work. That doesn't work for me. That's
they
the
can
wrong.
be. I mean, if it's rotated, if it's both rotated and closed, then it would
Technically,
be union.
I could form two unions, but it's not going to work in terms of voting. We're not, you can't vote on all the states of it. So imagine I have the car, and or even the stapler, and now I have a union of S1 and S2, and now columns are going to vote on it. They can't vote on both of those things at once. They can't. They're not observing both those things at once. They're only observing one thing at a time, and they're attending to one part of this object. And so throwing in, if I'm attending to the top of the stapler, including the SDR for the green one, is just, it doesn't do anything. It gets in the way. There's no voting on that. You can't vote on it. No one's observing it. So if no one's observing it, you can't vote on it.
Oh,
Well,
okay.
it's a point
I
of
don't see
voting.
the issue, but maybe we should let Jose ask her
Okay.
question
By the way,
when he comes.
on my screen, I always have to take off people's pictures, so I don't see who's raising their hand. So otherwise, it blocks too much of my screen. So
Ah, yeah, no worries.
well,
I was going to
I'd rather
interrupt
someone
soon
just
anyway,
speak up and
so
just say speak up.
yeah. Actually, I'll let Nils go first. Yeah,
No, it's
if
okay.
you're cool.
No, you go.
I think mine was slightly tangential. The way we're talking about states, going back to our car example, there's states of individual components like the lights being on, the doors opening, closing, windows opening, closing. But for cars, I don't think about the car state as a combination of those things. Like I have a separate kind of category. Like is my car on or not? For the most part, that's what I care. Like that's the state of the car that I care about. And if the car is on, generally that implies that the light is on, or I roll down the window. If the car is off, I usually have the window up. But like it doesn't feel like uh, and some car state might not correlate anything to the child state. Like the car could be on, but the seat could be in any position. So like I guess I don't see the parent state as like a combination of anything. Like it could be is like correlated in some cases, but like yeah, I guess I'm kind of defining in this case like the state as more kind of
Yeah,
Yeah,
yeah. I
speak to
think
that
we were
object
arguing
level.
for that in Milan as well, that they're kind of more the global car states, like on and off and driving and
and
park.
Mhm.
I
But
rejected that. I said
yeah,
that's there might be ones you care about more often, but if I'm just taking the groceries out of my car in the garage, I care more about whether the lift gate is open or not. I mean, that's
I see.
and I
yeah, and
don't
so
care about the car being on. And
yeah, and I was trying
Yeah,
for this to be a compromise where there are no privileged
I
states,
see.
but you can still have correlations between them. Like you could say, okay, whenever the staple is closed, this plate can't be rotated, or it will be
Yeah.
rotated, or something like that. Or with the car, you could still know that two SDRs, like there could be connections between that activate or inhibit each other. Um,
but I
Oh,
think your
and a quick.
intuition.
Okay.
Go
Oh, go
ahead.
ahead.
No,
A
Jose.
quick comment about the scissor thing is I remember so we have scissor open and then scissor close. I know this was like 20 minutes ago, but the state two for the scissor close is not the scissor because it would have to contain information that okay, we have parts here, but we don't have parts in the other like open state. So it's kind of like having two scissors imposed, right? Like they're not equal because the first one, the default is just that's the scissor itself, but the closed one is like two scissors imposed. Just that's a
yeah,
nitpick, but yeah.
Yeah,
right.
which
Yeah,
is
no,
why I kind
you're
of feel
right.
like, yeah, rather than inhibiting, like I feel like we could tweak this a bit where it's more like each state, it's more about predicting just when there is a feature, um, rather than ever kind of inhibiting not to predict something. So I think overall this is yeah interesting and I think we could work you know into something workable or whatever. And then, like the strangest thing I guess initially when you're describing it is just that yeah, in order for this to work, we need to have this union of states active in order for them to. And this was, I think, an issue before. I just hadn't thought about it, or a weird thing. They need to be active in order to condition, like L4, say, like those neurons actually need to be spiking. But actually, I think the same thing exists, but
Well,
I don't.
I didn't follow that. Could you say that sentence again?
So, as in, like, if we're saying,
If
okay, we're in this reference frame, so it's a single
yeah,
activation.
yeah.
What we're going to see in L4 is going to be dependent on what states are active in L3, say.
Okay.
But
Yeah.
in order for L4's like neurons to be conditioned, as in to be like in a predictive state or whatever, depending on the state in L3, obviously the neurons in L3 need to actually spike. But then that means
Right.
kind of all of these are spiking, and that maybe means weird things for like communicating information up the hierarchy. And like, are we saying, oh, all of these states are active and stuff like that? But I don't think that's a unique issue to this because actually, even if we look at the alternative solution, in order to infer the behavioral state, that's normally we have, like a single reference frame and we're trying to predict like, okay, where are we in the sequence of the stapler opening? Again, we're going to predict a union of locations in that state in order to predict what local feature we're going to get.
I'm not sure we do. I mean, remember the I don't know what we want to call it. Idea B, the one I'm proposing. Okay. Each feature you observe in the morphology model is uniquely identified to a state in a behavioral model or
But-
no state.
But let's say the
in a behavioral
object's
model.
moving and we're just trying to infer it based on movement.
Well,
Yeah, like you're trying
that's
to recognize the behavior.
right.
Like we're just trying to
So
recognize hinge behavior.
right. So that is an issue of the behavioral model, and which is invoked by movement, and so we should talk about that. So that's what I've been working on the last couple of weeks, the last couple of days, actually, just to try and understand exactly what are these models absolutely representing? What language I use for the different cells, and it's I think there's a refinement that might be necessary in our thinking. It's not even a change; it's more of just a clarity and refinement of what our models are actually modeling. So I'm not through that yet. It's head scratching still, but there's issues to work out, and so we have to issue like, how does the behavioral model infer? What is it actually getting? What is its input actually being? And so on, things like that. But
Yeah,
in
I guess,
terms of the morphology model, which is today's focus mostly, the morphology model doesn't infer behavior. I think the morphology models, its features just tell you, if I see this feature, then I can tell you what behavioral model I'm in and where I'm in that behavioral model.
yeah.
Um,
Well, I guess the question is, can morphology models infer state, not behaviors, but their state?
they're not even
And I guess
inference; it's an observation.
if the objection
It's
is
not.
the idea of multiple SDRs being unioned in L3, like it feels like we have that already in the behavior models.
We
Yeah.
don't. There's no inference on from the morphology model point of view. A feature is just an observation,
But
and there's no inference of behavior states. It
no,
says
not
I'm
behavior, but
observing this. I'm observing the state. I'm observing it by looking at the feature that's there. That tells me the state of this feature. There's no inference beyond that.
I mean, I
Nothing else
think
is
Neil's referring
required.
to this proposal or the earlier version where we have states in morphology models, so we have to infer the state that we're in.
Right.
And so
And
to infer the state, we start out with all states are possible, and then our observations can narrow them down. And we propose the same mechanism for inferring behavior. In behavior in the beginning, we could be in any point in the behavioral sequence, and then as we get feature input, we figure out where in the sequence we actually are.
well, what I've
So it
proposed,
would be the exact same mechanism.
but if you observe the behavior, maybe I'm just not understanding what you're saying. If you observe the behavior, you know what point you are in a behavioral sequence. I mean, if you observe a feature, if
Well,
you observe a
How
feature,
is that? But that's like saying
no.
if you observe a feature on an object, you know where you are on the object. You have to start with multiple hypotheses and then narrow it down.
no,
Yeah.
if I know what object I'm looking at, switch plate, the car, or whatever, and then I observe a particular feature on that.
Well, that's not a
But
given.
now we want to
observe
observe but if we want to observe the behavior without relying on the morphology model, because if we
Oh
want to
no, no,
generalize
no,
behaviors,
right.
if we want
Okay,
to
so
generalize
let's
behaviors, we need to recognize, for
right,
example, hinge behavior
So I'm
independent
just
of stapler.
let's just separate these two out because those are two separate problems. All I'm pointing out, if we're talking about morphology, I do not need a behavioral state. The behavioral states are the features themselves. So I've knocked that one. In that way, it's such a simple solution. It's beautiful in my mind. So
Yeah,
done. No,
I'm not talking about morphology.
now we can ask a separate question of, all right, how do we recognize a behavior on a new object? Right. That's really what we're talking about. And that's a separate question. I don't think we were dealing with that today. We need to go
Well,
down to behavioral models and
The,
what
the
they
reason
are
I brought
I
it
mean,
exactly.
that
up is
was
because
one of
I
the
think it's
beauties
the
of
same.
this solution, that we could recognize behavior and morphology independent of each other. We could recognize a behavior on a different morphology that we've never seen it on before. And
Why is that? Why did that go away with my proposal? I don't understand that. Why
Well,
do
if
you
you're
think that's
saying
not?
that the
If it's
feature
using the same
uniquely
mechanism,
identifies,
yeah.
What, you guys both spoke at the
Sorry.
same time.
if you're saying the feature you observe uniquely identifies the state in the behavior model, this is very tight coupling between a specific morphology and a specific behavior, isn't it?
Right, on this particular object, right. So I
So
want
how
that.
would you
That's
recognize
but that
this
doesn't mean
sequence?
I can't infer the behavior on a new object.
So
Uh,
how do you do it?
so this is where I was getting at. It's almost like I don't know, right? But I want to put an anchor one place and then work on the other parts. So the anchor I want to put down is that this simple idea for representing states and morphology models works. Now the thing I'm trying to understand, which I don't think we really understand at all, is the nature of behavioral models. I'm really confused by it. We made this major change to them by suggesting that we're going to use this sort of broad field movement vector to represent the movement of a child. And that was like a big change. We didn't work through all the issues with it. And so now I'm very confused about what exactly behavioral models look like. And so if I think in my mind, what I need to do, or we need to do now is focus on behavior models again and say, okay, given a newer understanding that they're always paired to a child and that they're linked to the parent via this, this feature observation. How do behavioral models work? And given the fact that now they're representing not the movement, the local movement, but a broader movement that it requires, an attentional window. None of that we had. So to me, it just opens up like, oh, we have to spend more time on the behavioral models because I think we've thrown a monkey wrench into them. We've made a huge modification to them where they didn't walk through the consequences of that modification.
But does that modification influence this question? Because
It
to me,
certainly influences the
this
question
question
is
is just
how do I
if
infer
you.
behavior? Sure.
Well,
Totally
yeah, I
does.
mean, I feel like this question is just about if you have learned a sequence of either states or features, you learned a sequence of things, and now you need to infer your location in that sequence. And it doesn't matter whether that sequence represents, like whether the points in the sequence represent object movement, or whether they represent flow bits, or whether they represent a melody. It's just about inferring your location in the sequence.
Oh, we know how to infer a location in sequences. The temporal memory does that. The question is, what is the temporal memory representing? Temporal memory infer location. You feed in a bunch of, essentially outputs of the spatial pooler, and it'll figure out the right sequence. So the question is, what is the behavioral model actually
But yeah,
representing?
that relies on a union of SDRs.
Yeah.
Right, but it's a union of SDRs in layer 4. It's not a union of temporal pooled. It's a union of SDRs in layer 4. It's like a union of all the next possible elements in the sequence.
Is it?
It's not.
Because I feel
Yeah,
like
that's
we've
what it
often
is.
said it's actually more L3 for the behaviors. Because
No.
Yeah.
We're talking about.
because
I'm talking
I
about-
thought we agreed that state for behaviors is like object level.
State, right, but it's a separate aside. We were talking about a sequence and recognizing a sequence of behavior, a sequence of elements. The temporal memory does that without any temporal pooling. It's just a temporal memory does that. In fact,
But it only works in.
we never relied on any temporal pooling when we tested the temporal memory. In fact, there was no. It's one of the things people say. There's almost no connections back from layer 3 to layer 4. And so we almost took that as a given that there is no feedback to this thing, to the temporal memory. So I'm just trying to pick out words. You said a phrase like, how do we recognize the sequence of the behavior? The temporal memory does that. It does not require temporal pooling. If you feed in an ambiguous sequence, it'll figure out what the right sequence is, and
But that
lock
only
onto
works
it.
because there's no space, like because it's just a sequence of features. But now that we have a reference frame that we can move in, and we can move through that reference frame independent of how we're moving in time, we need a kind of pooled representation of where in time we are to know which things to predict at what locations at that point in time.
I didn't follow that. I need a picture for that one.
Um,
I mean,
like
look.
now we have a
Okay.
space here. It's not just feature A, feature B, feature C. It's there can be different movements or different changes at different locations depending
Right.
on where you are in the sequence.
But if
And
I
so
have an
you
SDR, if
couldn't
I have
just
an
do it
S,
in layer 4.
you could. If layer 4 represents both space and the element, layer 4 will do it. In fact, that's layer 4 always does that. Or layer 4 always represents space and the element. And it's just if if that changes in time, and it'll learn the flow of them.
Well,
It
how do you
doesn't
mean
it
it
layer 4
represents space?
because it's got layer 6 projecting to it.
Okay, so
Just like
layer 6 represents space, and it,
all of our models have an object space, right? So,
yeah.
and that's in layer 6. They all project to layer 4. Every model we've ever done has this. It's like, so layer 4 represents, it wasn't orientation, but now it would be a movement or something like that. But anyway, it's a combination of an orientation, a feature, and a location. And uh and that's true in behavior models too. The layer 4 cells don't know what the SDR means. So if it's encoding space too, it's encoding space.
Yeah,
So
but
But
layer
like, as in
6 is the
if in
same reference.
L4 we see a particular feature moving, so that tells us like the hinge behavior at some part of the hinge.
well, actually,
Now now we
what
move.
we no, it's interesting. It's really weird. This is where I think we have to rethink. We have to go through this model again. I think the change that Vivian suggested of going to a sort of a global, object level representation of movement, it changes how I think about this model. I think we haven't walked through all the consequences of that. Maybe it'll be easy, but I'm struggling with it right now. So, until we figure that out, I can't, maybe you guys have it in your head, but I don't have a good understanding now what a behavioral model is anymore. I know the basics of it, but and now I'm a little bit confused.
Yeah, I
It's
mean,
like,
I guess I'm up for exploring that. I think the reason I brought this up was basically I was going to say if we were relying on the same thing we did before, then I don't see how we can object to some of the things that we were discussing today. But if we're
I
saying
don't know
this
what
is also going to be an
you say.
entirely new mechanism, then
No, no,
okay, fair
no,
enough. Then we need to figure that out.
I don't know what you mean by relying on what we did before. Um,
To
so I don't know
By
what
introduce
that
them
means.
in the
having a
beginning.
superposition of states in behavior models in order to infer what state we're in.
Okay, in general, I mean, I've always felt like, at least from the biology, I don't know how we meant implemented in Monty. You've got a series of SDRs that pool into a single ID, right? The general rule in biology is that doesn't go backward. I can't look at the ID and predict the individual states. The connections don't seem to be there from layer 3 to layer 4. Maybe they're there and people didn't call them out. I don't know. But I've always taken it as that it's a one-way street, right?
But then
And
why does voting help? I mean,
because
isn't
voting it's not just voting tells it, because we did come up with this idea recently that the ID can be tied to the anchoring of
right.
the grid cells, but it doesn't tell you where you are. It just says,
Yeah.
okay, I can vote on ID. Therefore, I can, if I know the ID is always associated with a particular anchoring mechanism. And we don't understand how grid cells get anchored. Nobody understands that.
Yeah,
So
I'm
it's
not
a
saying
mystery.
that layer 2, 3 representation could tell you where you are. I'm just saying if voting helps, then there must be some way for layer 2, 3
What it
to
can
have
do is
backward influence.
it can tell you what object you're on, and therefore it can limit all your searches to that object. Right.
But
So
that's exactly the same mechanism. It tells you
no, it would
what
go to
object or what state you're
layer
in.
6. It wouldn't go to layer 4. And you do see that connection. You see like connections from layer 3 to layer 6. So knowing the ID would somehow anchor but it wouldn't tell you anything specific about what feature. Well, if you knew your location, then you could make a prediction. So if I know, if I anchor my grid cells and I can and I know, and I can observe a feature or something like that, then I could, I can know where I am. Anyway, I think we can work through these details. None of them seem daunting to me. I'm just pointing out that we've in the past we've never relied on the ID to predict anything in layer 4. That it doesn't have
Well,
the brain doesn't seem to do that. Not
I mean,
directly, it can indirectly
implicitly.
do. Yes,
Yeah.
indirectly it can do that, right? Indirectly, maybe I think the evidence would be
Yeah.
it goes from layer 2, 3 to layer 6, and somehow that makes it work.
Right. Yeah. I mean, I agree with that path, but it still seems like, okay, maybe it has to go through layer 6, but still, which object ID is active in layer 2, 3 helps you predict which features you want to see.
Only indirectly, right? Not directly. That's my point.
But it
But
still does it.
that is an interesting problem, I think, for all of the proposals we have right now. If
Well, it's not
layer
clear
2,
to
3
me.
can't predict, can't directly influence L4, because in
It
general,
can. What's wrong with indirectly influencing? It doesn't wrong with indirectly influencing.
because basically we can go to the same location in the reference frame, but depending on the state, we're going to predict something different in layer 4.
Well,
Unless
we can.
unless
So
we're having a totally
we
different reference frame for each
we
point in the
we
sequence,
could
but then
we could
that's not
we
great.
could imagine a column is observing. It's only observing some part of an object. It's not observing the whole object. And the part of the object observing is associated with a particular behavioral model. Not all the behavioral models, just one. So, and I can vote on behavioral state. So I'm voting on the object. I'm voting on state. I know no object I'm on. I mean, and so I'm not trying to. It seems like I have all the information I need, or at least a lot of it. I'm not certain what the problem here is.
I'm still just talking about just inferring behavior. I don't have any morphology model to tell me what behavior it is.
Okay, well, we should have a separate conversation about how to do that. It's like so. A good example there is you can observe a behavior through motion capture dots, right? And so you don't really have to have any morphology object at all, right? It's just motion capture dots. So if you see them, you can't recognize any structure until they start moving. And we actually did that early on in the method. We tested a motion capture data and make the temporal memory works with it. But I don't know how it works in this case. So that's one little thing on the side here. We should be able to detect, just from little movements. Another thing which is puzzling to me, I'll just put this out as a problem I don't understand. So like if I look at someone walking and I look at motion capture dots walking, there might be several on the legs and several on the arms and the torso, whatever. And I say, oh, that person's walking, that person's running, that person's doing jumping jacks, whatever it is. What we've described so far, a behavior always is associated with a single child. That's what we kind of concluded in Milan. And yet here, when I observe someone walking, there's lots of parts. It's more like Rami's exploding logo. All these parts are moving sort of semi-different directions. And yet I had a lot of trouble recognizing Rami's logo and learning it, but I have no trouble recognizing someone walking as a single thing. And I don't think I have studied people. Maybe I did, but I don't think I ever studied people saying, let's look how their thighs move. Okay, let's look how their torso moves. Let's look how their arms move. And let's find the correlation between all of these. Somehow we just seem to recognize the entire flow of walking as a single thing, not as components. Yet that seemed impossible to do with the exploding logo. So it was like, wow, what the hell's going on there? Why couldn't I just look at the exploding logo and say, yeah, that's just like walking? And maybe I would. Maybe I just look at it and go, I
I
don't
think
know.
you would. I think if you kept
I don't
seeing
know.
that pattern,
Maybe
you would have this
right,
sort of like non-specific flow that was
right. So
kind of
maybe right. And
yeah.
so maybe I would make poor with Rami's exploding logo. If it changed a little bit from here to there, I wouldn't notice it. Maybe I wonder
But
would
you
I
could
notice
infer
it?
it. You could
Well, yes,
recognize that
right. But
was yeah.
if one of the components did an extra twist someplace or moved a little further over, would I notice it? Where I think if I saw, I don't know, but if I saw motion capture dots of someone running and a few of them were just slightly off or something, I probably would notice it. I don't know. And
Yeah, exactly.
it may
Yeah, I
be,
feel like a lot of that is kind of model free. So it's basically it's like a complex feature
is it model
that
free running? Is it
that's how
model free?
I've been thinking
Yeah, I
about it.
think
Well,
that
how could it
was
be model
maybe like
free? It
that
must be
was kind
model
of the
based.
extension of the idea of detecting whole child object movements, that like besides just detecting the child object moving in different directions, we could also kind of learn like put representations of like waves moving, or I guess a
Right.
person walking could be one too. Where yeah, I mean, I still I was thinking about
So
that a
my point
bit,
of
and I'm
this,
not sure yet how that would become rotation invariant, for example. But
my point
um,
was
yeah.
we reached one conclusion that behaviors are associated with a single child at a time. And now we have examples where that's not true. And so I'm confused by that. So I'm trying to reconcile those two.
But yeah, I feel like kind of having like if you just think of it as like a complex bit pattern sequence, like as an input to L4, I think you can just learn that like, okay, yeah, this is kind of the thing that tends to like another thing might just be like,
Right.
I don't
You're
know,
right. So
the feeling of like something like expanding or whatever. Like all of these could just
but
be different.
so
Yeah.
I went down that path too, Neil. So that says basically I can look the spatial pooler, which is the outputs mini column, has no idea what it's looking at, right? It has no idea. So what if I feed the spatial pooler a bunch of movement bits that represent movements, and then it could, in theory, learn a representation of a complex movement. The problem is that the output of the spatial pooler has a limited representational capacity. It can't represent lots and lots of things. So this is why you see it representing, really, a dozen things kind of thing. It's like, oh, movement in different orientations or edges in different orientations. It can't represent thousands of things, at least not as we look at in biology. So it's possible the spatial pooler could say, this is such a common pattern I see that I will form a representation in the spatial pooler. That's you can't do that very much. The spatial pooler has limited capacity, and so it feels like, okay, am I doing? I don't know. That seems kind of asking too much of it, because how many things can I recognize, like a waving tree and a person's behaviors and animals running
I
and
mean, yeah,
leaping and
I
all.
think like waving leaves, which probably activates like a similar representation to like static on a TV screen. Like you say, there's not going to be that many,
But
but
there
it
are
would
a lot, like the different ways the different animals walk and move. Like
Right,
even just one animal, like a cat, moving, running, laying down. Like there
it's
are all
different.
these patterns.
Right, right. I mean, I think Arthur would look different than a cat with motion picture plots and motion picture dots on.
Yeah.
So then this got me said, look, our system could learn that if each column attended to each section, like if you learned it serially, right? You looked like, oh, I'm going to look at one part of the object and how it's moving. Then I'll look at another part of the object and how it's moving. I'll look at another part, and we build up a serial we do the classic sensory motor learning. But it doesn't seem like we do that. I don't recall ever thinking about like looking at individual parts of a dog or individual parts of a cat. And somehow it seems more of a Gestalt thing. So I'm really I think I don't know, I'm struggling with this. I I feel like there's an answer because we're getting more and more corner cases that don't work. But I don't think we have the answer to this yet. There's something else going on here fundamentally that I think is fundamental to our models that we're missing. And
and so you're concerned with kind of a like yeah, learning like a flow pattern of over a larger receptive field is just that we wouldn't learn enough
I'm
or
also it's not even that. It's like also when I can recognize the problem of recognizing line drawings. Recognizing line drawings is a little bit like recognizing flow patterns. There's no other detail, right? It's just I'm not filling in any kind of color and hue and complexity. It just what are the and I'm looking at like an oval and recognizing it, or I'm looking at a square and recognizing it, and or an oval turning into a circle. We don't really have good solutions for these. Where are the child objects? What is the resolution of which I'm learning? Do I learn an oval by looking at each component in sequence? Like that's what we would say today, right? The thousand brains theory would say we have to look at each edge as a child object and recognize all its orientations. And now I could vote because I'm looking at one little piece and somebody's also looking at another little piece. But we'd have to know exactly our relationships to each other. We'd have to know exactly the different columns. We'd have to know exactly where they are to know that this is an oval, not a circle or something else. And I just feel like we never solved some of these problems. So all of a sudden, I'm thinking like line drawings are like flow patterns in a behavioral model. Like it's just pure edges. It's just pure motion bits, or this is just pure static bits. And how do I really recognize them? Do I recognize them by learning the component pieces and how they move? And what would those component pieces be if it was a motion captured image? Um, it just feels like there's something else going on. There's some level of more of a Gestalt sort of, I'm not throwing away the thousand brains theory. We still build models compositionally through sensory motor inference and all that stuff, but there seems to be another level at which, when I'm not dealing with composition, or I'm not dealing with sort of a complete sensory motor learning system, somehow I'm able to get these Gestalt behaviors and Gestalt shapes. Um, I don't know. I don't want to put an answer on it yet. I'm struggling with this. Uh, I, I,
Maybe
I
running is
feel,
like a
yeah,
maybe running is like maybe our could be an example of a compositional behavior. Like I feel like running is a behavior. If I had to choose a child object for to which running applies, that applies to the entire human being and not necessarily like one arm or leg. But you can see
right,
that one arm or leg is like swinging, like that's the but
right,
the
right. So
running
my point,
strictly is like you have to swing this way. You can't go
what,
like
right. So my
this.
point is, right, we would have said in the past, or we say
Right.
right today, that Jose, we would say I'd have to learn the different components, how they're moving. How does the forearm move? How's the thigh move? How's the foot move? These are different components, like learning parts of an exploding logo. And I could learn them by observing the behavior and over again. And I could build up this sort of model of a behavioral model like that. But
Yeah.
it doesn't feel like we're doing that. I mean, maybe we are, but it doesn't feel like it.
It doesn't feel like it, yeah.
And then
Because
and then
I
there's this
think, yeah, there's a
there's a
funny thing,
question.
yeah.
Go ahead.
Sorry, I think there's a funny thing like where if you actually really think about walking, then you suddenly like trip over or something like that.
Right. Well,
Like, yeah,
you don't really realize what you're doing. I mean, that's a separate
right.
issue. Like
Okay, fine.
the walking and running could be just they're subcortical. They're
That's true.
they're the
Yeah.
old models in the spinal cord or something like that. But we can learn it and we can observe it and we can infer it. And so the question, how do we do that? I do think this gets back to the issue of learning a circle and an oval. I think they may be parallel problems. It's like somehow I doesn't feel like I learn a circle by observing all the little components one at a time. There's something else going on. I don't know what it is yet. Um,
The
yeah,
whole is more than the sum of the parts. Kind of,
right. That's a good way.
yeah.
That's the way of putting it. Right. It feels that way. I mean, does anyone disagree? Do you feel comfortable that we know how the Monty could learn a circle?
You mean because you don't want to discretize the points on the circle, or
Well, we don't know how to discretize them. And it's not even points, right? What I've come to realize is that what a column, even V1, if it's detecting the orientation of something, it's detecting an orientation based on what you said in Milan. The orientation has to be calculated over some area of the retina, and the feature that it's representing it has to include that area of the retina, not more, not less. All right. So because if the feature is more, then the movement vector is incorrect. It's not we determined that. And if it's less, it's also incorrect, I think. So somehow you have to match the area of your detected movement with the area of the feature that you're observing moving. And so where do I make that distinction on the circle? Yeah, I don't know. When do I say this is this location, or this is this location, and this is at this location? In the past, I've argued that we do some sort of extrapolation in between. That may be the answer, but it still feels a little weird to me. There's something. It just feels weird, and it's the same question as how do we infer behavior by motion capture dots? I think it's the same. It's a very similar issue.
I mean, for what it's worth, yeah, I feel more comfortable with line drawings like of squares and even like a line drawing of an airplane or something. Um, which makes me wonder whether again the oval and circle could be again more model free. Like, I mean, it'd be pretty easy for at the lowest level to just represent a blob of intensity of different shapes. Um,
It almost feels to me like here's a crazy idea. I don't believe this is true, but here's an idea I was thinking about. I was thinking about attentional windows. And at one point I said, the attentional window changes and get larger and smaller. Well, that suggests to me that the thing I'm feeding into the spatial pooler would be getting larger and smaller. Maybe that's that's not necessarily true. It could be just the size of the apparent object, but it could also be somehow affecting the size of what the feature that's being sent into a column. And so I was asking myself, could the spatial pooler do different things under different size attentional windows? Could it on a larger attentional window, could it represent more things? That are more plane-like or dog-like or something like that. I don't know, but again, none of these are throwing away any of the basic premises of the thousand brains theory. I don't want anyone to get spooked by that. It's just more like refinements of what we have. I think we haven't really thought through exactly, attentional windows, locations, and how they relate. And I really got kicked off by Viviane's suggestion to Milan, which is like, holy crap, I was thinking we were detecting these movements at different locations. We're not. We're detecting the movement of an entire object. And that's not what the retina is observing. It's calculated.
Yeah, I mean, I feel like I'm a lot more comfortable with saying, yeah, we're detecting movement of an entire object before it goes to the cortical column, than saying that we can detect complex movement of several parts of objects relative to each other. I feel like that's still something that needs to be done in the column with a reference frame, because otherwise, like, just detecting the movement of an object in a direction, that's not rotation invariant. We have to learn it for each direction that it can move in, and we have to
Mm.
rotate it when we rotate it into an object's reference frame. And if we have to do that for all the other complex behaviors like walking and a cat sitting down and whatnot,
Well,
it,
so
it just seems like, yeah, a lot.
we've talked about objects seem to have a sort of a default orientation in the world. At least many of them do. And when you start rotating beyond a certain amount, then it gets confusing. So if I saw motion capture dots upside down of someone walking, would I say, oh, they're walking upside down? I'm not sure I would do that. Just like we've seen, you might be able to do that. I don't know.
But to a certain
But
degree, at least, like you can watch TV while having your head
Right, a
tilted or
little
Yeah,
something.
bit.
I think it could be rotation invariant, but I was more thinking like, yeah, the information coming into L4 isn't this richer kind of representation. That's L4's job to encode that based on all these primitives. But that potentially means we can also rotate it as it's coming in to give us
So,
rotation invariance.
can I throw out another idea I had recently, just like yesterday, just to throw into the mix? It occurred to me a column. I was trying to make a distinction, like what is happening in the primary column, like V1, versus something really high up that's recognizing an intersection, and things in between, V2 and V4. And we said, well, we know V2 gets input from the retina, but it also gets input from V1. And so I don't remember how I got this, but I came to the conclusion that a particular column might always do the following. It might always try to get some sort of, think of it like a retinal input. And of course, they could have different scales. V1, they're not be small, and V2 bigger, and so on. But maybe it's strict. But they would go through two phases. The first phase is trying to recognize this thing via just this sort of line edge type of thing. And then the second phase is it starts attending to child objects one at a time, because the child objects are very definitive, but it takes time to do that. And you may not have child objects, but if you do, so it's like somehow I open my eyes and I see, oh, there's an intersection, and then I start saying there's a car, this, and this. I didn't say, oh, there's a car, it's fine, I'm at an intersection. It seems like somehow instantly I know there's an intersection. Like when I did that flash images for you on the Zoom call, and you said, oh yeah, that's a boat, right? And you didn't really have time to attend to the features of the boat, and there was a complex scene, so it wasn't just. I know it just feels like a column would do this. It would say, I'm going to get some direct input. I'm going to do my best to infer that, and now I can narrow it down by attending to child objects. So it goes through this multiple. It's consistent with the heterarchy, but it's just saying there's this like idea that a region would do first a childless inference, and then rely on attention in children to really narrow down and refine the model or refine the inference. And we see
But
that often V2 recognizes an object before V1. So, that was an early neuroscience result.
But for the kind of child, I mean, I agree with the general framing that like you first try to do as best you can with the direct input, but then wouldn't voting also play a big role in this kind of flash inference
Right, right. But it
instead of
seems like it's like something like when I think about the intersection, I'm trying to put my fingers on what is it about this intersection that I see it right away? Or if I flash a building in front of you, what is it about the building? I mean, it's like it's hard to say what the components would be that that individual columns are assigned. It's like it just seems too much to ask. I don't know. It might work. I mean, in theory, it should work. but it feels like there's something else going on. And when I go down to the extreme of like an oval versus a circle, then I think that maybe sort of highlights some of the difficulties of this.
Yeah, I
I don't
guess
know
the
to get into
difference would
this.
be like if we think about the alternative voting on location mechanism we talked about in London, where you basically broadcast a set of locations to all the columns. You could
Right,
infer a
right.
boat based on the set of locations on the boat, like the rough shape of it, as opposed to having a model freeway to recognize the shape
Yeah,
of boats at different orientations.
I know, I know. It seems to happen so fast. Um, I don't know.
Yeah.
I don't have a great definitive explanation of the problem, but I'm suggesting there's components of it. I'm suggesting that I'm giving you hints of why I'm bothered. I can't determine what are the segments on a circle that I should care about. The precision of a circle versus an oval seems too much to ask for these mechanisms we're talking about. Um, and and then uh, and then there's issues of like, what features of an intersection I'm recognizing as an intersection before I recognize the details of it. I mean, it's just struggling with it a bit. Um, I don't know. Maybe I'm over worried about it, but it feels. And then this gets down to the issue of learning
Yeah.
how do you infer the behavior from motion captured dots? It's the same kind of Gestalt thing. No children. I have no children. I'm observing no children moving. I just have flow
I mean,
bits.
yeah, with our previous solution, I think we covered that. Like it would have been able to infer a behavior just based on motion captured dots. Like basically, it would just be flow at different like movements at different
Yeah, but
locations
that
in the
but
reference
that
frame, and so you
solution didn't
can.
work because it required it's like enormous amount of training time, and we didn't even know if it would be able to train it. Because you'd have to go through over and over and over again the same sequence, observing different locations and seeing how they go.
Yeah, learning was a
And
challenge. One thing I had suggested was that at the higher level of the hierarchy, we could use this larger receptive field to like initially
right,
learn like a course
right,
behavior. And that could tell a lower level column, you're in a behavioral state, and that would anchor it so that it could then say, okay, this is a local flow that I'm observing, but I know where I am in this behavioral sequence because of this higher level learning module. And this higher level learning module, that's the one that's getting this broader input.
right. So the question I'm struggling there is the broader. If I'm a higher level column and I'm looking at a broader area, am I just turning it into mini columns of orientation of large areas? Um, they don't seem to see that in the cortex. They don't see like in IT or V4. I don't remember anyone saying, "Oh, this is just an orientation of these cells respond to orientations of large areas." They don't. They
I
seem to
thought
be
they
more
did.
specific. Well, let me
Obviously,
ask
it's
the
not the most
question.
classic thing that's reported, but I'm pretty sure if you look at like, let me see if I can find it. Tanaka 1996.
Well, some of
Also,
that could
while
be.
we wait, maybe can we let
And
Scott speak
yeah, hi
briefly?
Scott.
Hey, well,
Hi,
Scott,
I
hi,
just
just
had
Scott.
got
a
just got to
question about
just
the
got to
Gestalt.
shout, Scott.
Sorry.
No,
He's a
Well,
don't
nice
when you
guy. He
yell. Go
brought
doesn't
up,
ahead.
shout.
We want to
when you
hear
bring
your
up
voice.
when you bring up the Gestalt thing, I just wonder, like, a lot of other teams or whatever, they're kind of focused on statistical kind of inference, and I'm wondering if you're kind of moving down, like making room for more statistical, not explicitly morphological uh, um,
No, no, I'm not
modeling,
going
but
that
it's still
direction. No.
so it's Gestalty, but it's still sort of explicitly
Well,
morphological and
here's
geometric.
for example. Our models could learn this more Gestalt stuff. Just take like recognizing an airplane from a car line drawing type of thing.
Mm,
The way they could do that, you have to have a larger input area, and you'd have to have a spatial pool with many more possible output states.
mhm,
We did this. We started with the spatial pool in the temporal memory. We basically had the equivalent. We had a spatial pool that had thousands of output mini columns, if you right, not like 10. Oh, well, 2,000 bits. So we run the spatial pool, it comes out with 2,000 bits. Well, as soon as you do that, you can represent a lot of stuff in the spatial pooler, and that worked. Right now we kind of restrict ourselves because it looks like in V1 and other places you have a very limited number of mini columns that are unique, and they repeat, but they're not that many. So the output of the spatial puller is very limited. So, but I could take the spatial puller mechanism and feed it in a larger pattern, and it could learn a much higher, many more different output patterns that could correspond to airplanes and boats and things like that. And it wouldn't be hard for the spatial puller to learn that. But that would require that when you get up in the cortex, the column equivalent would be much larger. It would have to be like, it's not like a third of a millimeter in dimension. It would have to be much larger than that. And is that possible? It might be possible. But anyway, I'm just pointing out that I don't have to throw away the whole sensory motor thing and go to a statistical method. I can use all the same mechanisms we have right now if I were to relax that requirement about the number of mini columns that are output by the spatial puller. And it would learn things. It could learn many, many things, not millions, but thousands of things that you could Gestalt recognize.
But you also have to change the receptive field, right? Like you have to relax the input to the column size of receptive field.
Yeah, I think that's you don't have to, but it would be advantageous to pick a good one. You know what I'm saying? Naturally V4 looks at a bigger area than V2, which looks at a bigger area than V1. So they would have natural inclinations. If that's what you're talking about, Rami. I'm not sure.
Yeah.
Right.
Would
But
we?
again, maybe. Oh, go ahead. I had another thought of what you said.
No, I was thinking, and that would only be from the thalamus to V1, V2, V4, and it wouldn't be in the hierarchical connections from like the output of a column to another column.
Well, the idea of like a Gestalt recognition would not. Right.
I was trying to offload some of the computational complexity by just like if we do it in the hierarchy as well, we might be able to get away with the requirement of having too many output columns because we're doing it in the hierarchy and also in the input from the thalamus. But it's
well, I guess I was working on the idea that you go through this, at one end of the spectrum, like V1, you have no true children. I mean, your children objects are just, edges, I guess. And then so the Gestalt thing there would be very important. I've often said that I think you not only recognize letters in V1, but you can recognize even short words in V1. Single glance, it could happen in V1. But then you get like when I'm looking at really, really complex scenes, I'm almost completely dependent on children objects. I look at, oh, there's a building, there's a car, there's a dog, there's a this or that, and there's much less of the Gestalt part of it. There's some, but I'm much more dependent on children. And so it seems like we go through the spectrum of like the children are these really, maybe it's more of a Gestalt low level thing with very little children information to some place where we have very little Gestalt, but a lot of complex children. The example I was using, there's a sign on the intersection outside the window of the coffee shop where I work. And that sign, I recognize that sign. If I just see that sign alone, I know exactly where I am relative to the intersection because it's a unique sign and I'm looking at a particular pose. And if I know my pose of that sign, I know where I am in the intersection. I don't need any other information. There's no Gestalt, anything there. It's all children, unique child. So it seems like there's this spectrum between Gestalt stuff and truly, child object-based stuff. And in between, we have a mix of both. Where you do maybe the Gestalt followed by children or something like that. I mean, I did all hand waving. I'm making this up. So
if we're saying that we can kind of learn some Gestalt type features based on sensory input, is there any reason they need to activate mini columns? Couldn't they be the kind of feature ID input that activates specific cells within a mini column?
Right.
Well, how do you? Well, I don't know the mechanisms for learning that. You don't want to just take the raw bits. I mean, you got to recognize it somehow, right? You have to do something.
Yeah.
And so I think you do need to recognize it. And so I don't know how you do that.
I mean,
right?
It'd be like instead of having a bunch of centers around fields that line up to be a line, it would be a different combination to be a circle or
If
whatever.
if I just sent them straight to the cells in layer 4, there would be no knowledge of what that thing is. I couldn't handle any variation. The nice thing about the spatial pooler, it's by its name, it tells you what it does. It takes a whole set of patterns, almost an infinite number of patterns, and it maps it into a very limited set of patterns. And it does so based on statistics. Maybe going back to your comment, Scott, the spatial pooler is a statistically driven. It's a transformer from a high dimensional variable density space to a lower dimensional fixed density space, and it does it by statistics. Just how often do I see certain patterns? So I think that's still required. I think it's my point is that the number of things you can recognize with a spatial pooler, it goes up if you have more mini columns. And it's it's n winner take all. The n gets bigger, then you can.
Yeah, I just mean if we had a mechanism that can find the most statistically common patterns, and each of those patterns basically become a unique STR and activate specific cells in layer
Right.
4 instead of activating mini columns.
Well, I guess I don't know where that would be. I mean, essentially that's what the spatial pooler in temporal memory does. Could you do it otherwise? Maybe. I don't know how that would be. I mean, you
Yeah, I
get
mean,
this
just trying to think of a way
right.
where we don't need thousands of mini columns, but we can still represent thousands of or hundreds of patterns.
Yeah, and
but you have
or
the point
alternatively,
you
I'm
have
just
to.
wondering if different columns kind of specialize, like I don't know, then sort of different mini columns can be sort of sets of mini columns can be kind of tailored to different sort of tasks almost. I feel like that kind of constrains
Well,
the problem as well.
well, they are in some sense, and they're always that way. In some sense, basically each mini column represents some some subset of what is out there. And
But so I'm saying like as in like but then the column like a column it's associated with a set of mini columns but like maybe one column's let's if we're looking at behavior columns maybe one
yeah.
column's mini columns are like oh yeah it tends to get kind of animalistic type movements and then another one tends to get like kind of very rapid like expanding and shrinking movements or something and so like
How do
that
they know?
column's going to kind of be concerned almost with like separating those out
Maybe,
but
but
it's not going to
how
try
do
and separate out every possible flow
well
pattern.
the way the spatial pooler works, it doesn't care at all about what these patterns are, has no idea what they are. I'm just going to find the statistically most common ones, and I'm going to
Right, but
represent
you could
them.
imagine through like lateral competition or like there would be ways I think of kind of modularizing things, but
How would it, well, there'd have to be some external signal to tell one spatial pooler to learn animal movements and another spatial pooler to learn something else. From
I think
looking
it
at
would
the,
just happen naturally if they it's just like local minima that were kind of pushing each other away towards different ones.
well, that's what they do, but they wouldn't make a distinction. They make a statistical distinction, not like any on other sort of like animals versus non-animals,
Yeah,
something
yeah,
like
of
that.
course. I'm just saying that to
Um,
try and put some words to it. I'm not saying it would actually be
yeah.
animals.
No,
They
the
would make
point
a
is, what's
they
that,
would
Ron?
make a distinction of like animal versus non-animal or something like that if they're getting context from a higher level at the same time.
Well, if they're getting context, but if then that assumes that somebody else knows what's going on, right? So but begs the problem. How do you know that? Because you're trying to bootstrap a system that doesn't know anything. So yes, in the future, once I've learned all this stuff, I can use a top-down signal. But in the beginning, the child is just bits. It's like they don't know what it is. The brain's got to figure it out.
But like the whole thing that, when people put probes in the brain, they tend to see, oh, okay, all this region focuses a lot on faces and this whole region focuses a lot on animals and stuff like that.
Right.
Like none of
Yeah.
that is top down. Like that's just more kind of
Right.
natural competition.
Right.
Um,
Well, I mean, there's two ways of looking at that. One is some hard wiring, that somehow this part of the brain is designed for faces, which there's a good argument for that, but that doesn't fit into our theories. And then the other one, you could just say, well, we see a lot of faces and we see them early on, and therefore during these impression periods, we form higher representations of, mom and dad, mostly mom. And because those are the statistically most common patterns I see as a child, those are the ones that are going to get locked in as, my Gestalt behavior. And I think there's some, there's probably some literature in that if children were raised without, that kind of exposure to, like, I can't tell, one monkey's face from the next, but monkeys can do that no problem. And I can see, humans, we all look different to me, but I bet you monkeys look like, what the hell? They're all a bunch of, they all look the same to me. It's
Yeah,
hard to imagine.
I think there's actually some evidence that baby monkeys can distinguish humans, but then they lose the ability.
Well,
And they
right. So
think
that would be
baby
that.
humans
Right.
too.
So
Yeah,
that
and
would
baby
fall
humans
into
can
the
probably distinguish monkeys.
of the two hypotheses I threw out there. I would prefer the second one, which is, the system is generic. It works on anything, and it's not hard coded for faces. But because of early exposure, we design. We form good representations, the Gestalt representations of faces, and not of other things.
Did you
And
guys
so that
know
would
that the fusiform face area on the right side is used for writing characters? And
no,
Oh,
so
I
I didn't
didn't know
know
that.
that. I
for I
didn't
think
know that.
for illiterate people, it's faces in both
Really?
Oh,
hemispheres. But once you learn how to read,
But interesting because language is on the left side, right? So I would have thought, well, maybe the left side's got language and spills over into taking over some of the fusiform face area for writing or something like that. But if it's on the right side, that's weird.
let me
I don't get that.
I want to I'll post a follow-up to make sure I'm not lying about that, but I'm pretty sure that's correct.
You know,
Yeah.
I remember this paper from a guy at Berkeley, and I can't remember his name now. It's pretty old, but he was one of the first people who sort of really tried to, after Hubel and Weasel did their first experiments with orientation columns and mini columns and other stuff. People started looking for what the equivalent would be in V4. And this guy, and maybe his name will come to me, he did a lot of monkey stuff, and he tried to figure out what the equivalent to orientation columns in V4 were. And he got very complex answers. He didn't report orientation, he reported object-like things, but not in any kind of consistent way. And I'm not sure I trusted all of his data. This is early on. I'm not sure what to make of it. But at the time, it was like, he's not seeing orientation here in V4. He's seeing more complex objects. Now, maybe he was reporting from individual cells and not like, who knows? There's a whole bunch of, and because individual cells in our theories would represent more complex objects. But he didn't report any kind of the things he recorded, the equivalent to mini columns were more complex things. And so I wondered whether, is there really orientation as it sort of begs the question, are mini columns representing more stuff there?
Yeah, I
Yeah.
found the paper I was talking about earlier, which has a little bit of light on this. So this was Tanaka, who did like a lot of these classic studies in like Macaque
Right.
and kind of representation of objects. So,
What year is this? This is 80,
1991.
Okay.
And this is all looking at inferior temporal cortex. So this is all quite high level.
You're right.
Like this is all beyond. This is beyond V4, but this is
This is the
this is
first
lower
region.
level. Oh, sorry.
IT is the first region people sort of say like the response properties are over the entire or almost the entire retina.
Yeah, and
So
classically
it's-
where like object representations are.
Right.
And then this is like earlier areas, and so this would be classically like simpler features and smaller objects, and then beyond this dashed line is later areas. And I
What
see
do you
an
mean?
MO.
When you say later, you mean above IT?
Yeah, a higher level
Okay.
in the hierarchy.
Higher than
And so,
IT.
well, the
Yeah.
higher part of IT. These are two different parts of IT.
Okay, so IT is now in multiple regions, and they're
Yeah, it's
looking
been
at.
broken up. And then
Okay.
IC and MO are two different monkeys.
Oh,
Yeah, I see. So this is one monkey, and this is another monkey. And then in the experiments, one, they were looking primarily for these simple features, and those were the results shown at the top. And the other one, they're looking for elaborate kind of face-like or object-like responses, and those are the results shown at the bottom. And so the sort of summary view is that you have in this highest level of IT, you have more of these kinds of things, and then the lower level of IT, you have more of these things. But what I think is
Mm,
interesting from our point of view is like, so that this is just oriented things. Obviously, this is just, they're just measuring individual cells. This is just what they could find that it was most active to. So, yeah,
right.
you have to be careful reading into it. And I don't know what layers they were recording from, but it's maybe significant that even at this very high level of cortex, they saw lots of these oriented cells, and even in like the very highest level one, they just saw these what do you call it? Yeah, responses, sometimes with quite large receptive fields. Um, and so yeah, so it just suggests that you know, we could imagine having in L4 in quite high level cortex, literally just like big oriented bars. Um,
Yeah, maybe. Well, though it seems like less so. They also have these elaborate things I assume are not simple things, right?
Yeah, but
Um,
I mean that's what I guess we've always
yeah,
argued that like depending on what size
predict
they
that.
were and stuff like that, and
Right,
how
right,
and they're
right.
not particularly ecological. Like they're where was it? I don't know if they have it in this paper, but it's like these kind of funky paper cutouts. It was kind of yeah, it's like stuff like this. So they basically tried to make these cutouts as maximally. It was kind of interesting. Yeah, so they'd like try all these different ones and they notice like, oh, okay, cell two is maximally responsive for this, also seems to respond for this, but like, so that suggests kind of some scale invariance or kind of distortion invariance. Um,
Mm.
and then, but I think they were literally there with like paper and scissors and kind of tweaking them to get the like best ones. Um,
That's, that's pretty funny. It's hard. Yeah, it's interesting, but it's hard to make too much of it. Um,
it was just this point about like, could we expect to have orientation type responses in higher level cortex? I don't think it would be crazy if there at least are some
right,
are getting that
right. Well, yeah,
more so
well,
than object ID inputs. But clearly, a lot of them are getting object ID inputs.
right. Um,
But are we saying that IT is getting direct input from the thalamus, or is that V1 and V2 are like relaying information up? Because I'm not, I don't know, I'm not sure about the anatomy if like the thalamus directly connects to IT.
If it's that far up. Um, yeah, I think when we looked into it, I think there are direct connections, but it's kind of weird. It's like higher order thalamus, but it could go via the retina or something like that.
yeah,
Um,
right.